that I requested all the students to join on right time so that you can go ahead. But still, we'll recall by the time I hope they all will join also. Am I audible to you? Is it okay?
Yes, yes, sir. You are audible, sir. You are audible.
Then in the last class, we have discussed about what type
Sir,
of waste are generated from the hospitals, and
sir.
generally about 80 percentage of waste is general
There
waste
are
in
waste
nature,
and 20% hazardous waste. Okay, sir.
non-infectious and non-hazardous 80 percentage.
Yes,
Infectious
sir.
and hazardous waste is about 20 percentage.
Uh,
Out of that, infectious and anomalical waste is about 15 percentage. Sharps about 1 percentage. Other hazardous waste is about 3 percentage. And you see like this. But
radioactive burn, sir.
yeah. For the hospital is concerned, why you are worried is the waste. Yeah, Subhash Naik Madam ji, are you there? Am I audible to you? Subhash Naik ji, am I audible to you?
Audible, audible.
Okay. Good afternoon. Yeah, just we are recollecting what we have discussed last week. And the waste generated from the hospital should be disposed of in environmentally sound manner. Otherwise, it is going to cause health impacts, not only for the patients, but also for the medical and paramedical staff within the hospitals. And the generated waste is not disposed of properly, that is going to cause impact on the environment as well as the general public also. That is what we have. And also we learned about the types of biomedical waste in accordance with the biomedical waste management and rules 2016. There are 4 categories of biomedical waste. Based on color coding, it is yellow, red, white, and blue. And the rules emphasizes segregation of biomedical waste at source of generation. And waste has to be stored safely in a safe location in accordance with the 4 color coded containers or bags. Bags should be non-chlorinated containers or bags. And also, for every waste bin or bag, labeling is a must as per Schedule 4. And also, the waste so generated like human, animal article waste, soil waste, and microbiology waste has to be disposed of within 48 hours. Means these 4 categories of waste, untreated waste, cannot be stored more than 48 hours. If you store more than 48 hours, untreated biomedical waste, then it is violation of rules. Rules also permits on-site treatment of facilities to the hospitals, provided if there is no any common facility within a distance of 75 kilometers. The laboratory microbiology waste, blood samples, and blood bags should be pre-treated at source as per guidelines issued by Ministry of Environment Forest or WHO, and the efficacy of treatment should be log 4 for disinfection if you use the disinfectants, and log 6 if you use sterilization, maybe autoclave or microwave. And also, we have to phase out use of chlorinated plastic bags, gloves as early as possible to provide, and also it is the responsibility of the hospital management to provide training to all the staff at the time of induction, and also thereafter at least once in a year is a must. Barcode system has to be established as per guidance of CPCB by all the healthcare facilities is a must. Of course, the timelines already completed. All the healthcare facilities workers have to be immunized against at least hepatitis and tetanus. All the healthcare workers have to be immunized. It is a must. Health of the healthcare the worker also has to be ensured by providing adequate PPEs. Without any PPEs, the healthcare worker should not be allowed to handle the biomedical waste at all. These biomedical waste rules are applicable to all the healthcare staff because of it is the rules are applicable to generation, collection, reception, treatment, storage, and disposal of waste. Therefore, the medical and paramedical staff are the generators of the biomedical waste. Their rules are applicable to all the staff within the healthcare facilities. Various technologies, of course, I am going to discuss it. I don't want to read it once again here. I'm going to talk about the non-burn technologies. At the time, I'll discuss once again. Healthcare facilities have to submit the annual report to the state political control by 30th June of every year
Yes, sir.
as per
Sir.
the prescribed format, Form 4 for the
Four.
previous calendar year. It is a must. make available the annual report on website in case of all bedded hospitals. At least 30 and more bedded hospitals, they have to have their own websites. All the bedded hospitals should have their own website. They have to upload all this information related to the annual report and other related matters. And the records has to be maintained at least for a period of 5 years. It is a must. In case COMFEST is not collecting the waste within the stipulated time period, that means maximum of 48 hours, then healthcare facility has to report immediately to State Political Board. It is a must. In case if the COMFEST is not in a position to take any waste from the hospitals, in such a case, you have to inform to the State Board that there is, because of this reason, the COMFEST is not in a position to leave the waste. Therefore, you are required to allow to store more than 48 hours of the generation of waste, especially if they got the untreated inferior waste. All the existing incinerator operators have to comply with the Dyson Furans within 2 years. Of course, 2018 is the deadline already. They are required to comply to the Dyson Furans parameter in the stack emissions. It is the limit that has been given is 0.01. It is a zero point 0.1 nanogram toxic equivalent per normal meter cube, whereas in case of mercury in stack emissions is about 0.05 milligram per normal meter cube. Therefore, these two are persistent organic pollutants. Therefore, one has to be very careful. The proper APCD should be there, then only they should be able to comply with the requirements. All the healthcare facilities and COM facilities have to ensure treatment of liquid waste to comply with the discharge norms. It is a must. How today itself I am going to cover up all the 4 topics. The class I will try to complete maximum up to 5:30. Then we can have discussions till 6 o'clock, please. You have to bear with me today because of first class I have not taken, but I don't want to leave the lessons without teaching me. I don't bother whether they pay or not, but still I'll complete my task so that it will be useful for your exams. Local authorities show a suitable site for development of competency. It is their responsibility. Liabilities in case of any violation, the action can be taken by state regulatory authorities or regulatory authorities under Section 5 and 15 of the EP Act. There are responsible authorities for management of boundary waste in the country are Ministry of Environment, Forest and Climate Change, Ministry of Health and Family Welfare, Ministry of Defense, Central Pollution Control Board, State Pollution Control Boards in the states, pollution control committees in the union territories, state governments or union administration, etc. Yes, please. Any questions? Any questions? Yeah, okay then. I request quality manager kindly keep your. I request quality manager kindly keep your microphone in mute, please. I request all of you kindly keep your microphone in mute, other than me, please. And also, we have seen how the yellow color coded waste has to be segregated into yellow coded the bin, or that is a must. How we have seen what type of waste will come, what type of waste will come into yellow color coded bin. That is what we have seen. That is, which includes human aeronautical waste. Then we also have seen that animal waste also will go into yellow color waste, and waste like microbiology, biotechnology, and laboratory waste has to be pre-treated. After pre-treatment of that waste has to go to the yellow color bin. Similarly, discarded linen, mattresses, routine masks and gowns. Yeah, may I request the quality manager kindly keep your video microphone in mute, please. May I request quality manager kindly keep your video microphone in mute, please.
Hello, quality manager, please mute yourself. Quality manager, quality manager, quality manager, please mute yourself.
Sir, kindly tell in video, please. In audio, please. Seems to be they can understand.
Quality manager, quality manager, quality manager, quality manager. Okay,
Yeah, I think he has gone out.
okay, sir. Okay, sir.
Yeah.
Continue,
Okay.
sir.
Thank you
Please
very much.
continue.
We also have seen cytotoxic. This is the waste, how the yellow color waste has to go into the yellow color bin and bag. It has to be placed into yellow color bin, like in waste, like human article waste, animal article waste, soil waste, blood sample, and blood bags. These samples has to be treated, pre-treated, then it has to go into the yellow bag. Similarly, chemical waste has to be pre-treated. That means by neutralization, that chemical waste also can go into the yellow bag. Expired or discarded medicine, all waste is to go into the yellow color bag only, except cytotoxic drugs. Cytotoxic drugs will go to separately yellow color bag only, but the
Separately.
symbol of not the biohazard symbol, it will be a cytotoxic C waste symbol will
Right.
be there.
Right, right,
Similarly, microbiology, biotechnology, clinical laboratory waste has to be pre-treated, and all this waste has to go into the yellow bag only. Similarly, this is what I told you, cytodrugs drugs has to go into the yellow color bag, but symbol, the label should be C label, C for cytotoxic. Then red color, the waste, all plastics will go into the red color bag or container, but only before it goes into the bag or container, it has to be mutilated in order to avoid reuse. Then all the needles and syringes, waste shops, all will go into the translucent container. It should be puncture proof, leak proof container, and only that container should be used for the purpose of storage of waste shops. It should be tamper proof, translucent, puncture proof, leak proof. And all the glass waste and the metallic body implants has to go into the blue color coded bag or container. This is what we have learned in the last week. Today, as far as the today, there are four topics I'm going to cover. One is on burn and non-burn technologies for treatment of disposal of biometric waste, on-site and off-site disposal options. First two we'll see. Afterwards, we'll have a gap of 10 minutes. Then we will rejoin for continuing on the international policies as well as the final version on the liquid waste management. Today itself, I will complete so that we will all can go by 6 o'clock, please. If you feel any not comfortable, kindly we will have a discussion rather than continue my lecture. You can, if you feel that not comfortable, you can ask me so that we will have a discussion so that you will continue to, you can take up much load, please. First, as a part of this is one of the topic in our course under Unit 21, burn technologies for treatment and disposal of biometric waste. You all know, I don't know, the earlier speakers have given this particular thing or not. Main components of biometric waste management is segregation source. First, segregation source. Then it has to be collected and stored safely. Third aspect is transportation. There are two types of transportation. Within hospital, from wards, from generation place to storage place, that is called what we call it as intramural transportation. Or within the hospital, the transport is called as intramural transportation, and waste which is there going from the waste storage yard within the hospital to the common treatment facility, that is called offsite treatment facility, offsite treatment. Therefore, transportation will have two set of things. One is offsite or onsite. Onsite means onsite transport is called as intramural transportation. Offsite means waste is going from the storage yard of healthcare facility to a common biometric waste treatment facility. Whereas final option is the treatment and disposal. After treatment, whatever the waste is generated, that has to be disposed of without any problem to the anybody. That is what the major components of biometric waste management. Now, what are the technologies suggested under the biometric rules is one is incineration or plasma pyrolysis. What is incineration? What is plasma pyrolysis? We'll learn now after few minutes. Second technology suggested by the rules is autoclaving, hydroclaving, one and the same, but only the technology is the difference. But purpose of treatment of waste is in case of autoclave as well as the hydroclave is one and the same. And other technologies suggested in the rules is dry heat sterilization or microwave. And shredding is also one of the technologies suggested in the rules in order to avoid reuse of treated waste or reuse of untreated waste. Combination of sterilization and shredding means you can have both combination, both autoclave and shredder. Shredder or autoclave can be there, but problem is if waste is not segregated and if you go for shredding, then it becomes a problem for segregation after treatment. Very difficult because of it is a shredded portion. Segregation of waste, depending upon the type of waste, is very difficult. After once the waste is segregated. And other methods are there. We have chemical disinfection using sodium hypochlorite solution 1 to 2 percentage. Other technologies are there. Encapsulation. What is it all? I will show you what is encapsulation. Encapsulation is one of the disposal option we have. Sanitary landfill is one of the option, and also disposable deburial. Disposal by debris is also one of the options suggested in the rules, but provided if there is no any common biomedical waste facility near to the hospital or within that area, then the disposal by debris is allowed. And also generally in rural areas, we can't expect any common biomedical waste treatment facility. Therefore, in rural areas where there is no any access to the common facility, then in such a case, the waste can be disposed of by rural areas. Treated plastics for energy recovery or the recovery of diesel or fuel oil is possible from the treated plastics, and therefore treated plastic can be used for the purpose of energy recovery or recovery of fuel oil or diesel, or that plastics also can be used for the purpose of road making. Of course, the treated stainless steel, the waste shops, they are generally stainless steel. That stainless steel is also recyclable now. The stainless steel manufacturers are taking that sort of waste and they are try to recycle the waste or manufacture different products. Now, having said that, the waste management hierarchy, what it says, prevention of generation of biomedical waste at source means first we have to keep target that as much as possible the waste generation should be avoided, prevented. By adopting different measures, we can reduce the waste generation. I think so. My earlier speaker would have told you about the how to prevent the waste generation as a part of the healthcare facility. I don't know whether he has taught or not, but still, the measures have to be taken by the hospital such a way that that measures will lead to reduce the waste generation. Therefore, as much as possible, waste reduction has to be, prevention has to be taken so that waste generation will not be there, so that we can minimize waste generation in the hospital. Secondly, if there is no waste generation is not is a possibility, we can't avoid it, then reduce, reuse, recycle, recover. The recover the things, the four R's, what you call it as 4 R's: reduce, reuse, recycle, recover has to be done. Here, reduction can be done by taking certain steps. Similarly, reuse is required to be adopted only after treatment only. Reuse means you cannot reuse. For example, simple example, the shops, operation theater, whatever the instruments which you use for during the operation of a patient, that instruments cannot be disposed. Generally, that after sterilization, that instruments can be reused. There is no possibility, there is no necessity to dispose of them. Therefore, these sort of things can be reused. Recycle. Recycle also is possible only after treatment of a waste, generated waste. Like as I said, the plastics can be recycled. We can go for reuse. We can go for the manufacture some more products, definitely. Therefore, we have to adopt 4 methods. One is reduce, reuse, recycle, and recover. Even after adopting these 4 methods, even if there is a the leftover waste is there, even after this adoption of these 4 R measures, still the waste is there. In such a case, only that waste has to go for further treatment and finally disposal has to be taken care of. Now, if you see the hierarchy, first priority, most preferred option is the prevention of waste generation at the hospital is the most preferred option, and treatment disposal is the least preferred option. Therefore, one has to follow the certain measures so that the hospital, whatever the waste is generated, is going to be disposed of safely. Now, the waste that cannot be recycled, reused, or sent for landfill or so, then all that waste has to be treated and disposed. It has to be treated. the waste which cannot be recycled, reused directly, then or the waste cannot be disposed in landfills. All that waste has to be treated. That has to be treated. What is the options available for us is one is burn technologies is the option available for us, as well as the non-burn technology is available for us. Now, burn technologies, there is incineration as well as the plasma pyrolysis. Whereas in case of non-burn technologies, we have thermal processes, chemical processes, mechanical processes, biological process. I already told you in my the earlier slide the technologies prescribed under the rules for the purpose of treatment and disposal of biomedical waste. Isn't it? Same. Now that has been categorized into two types. One is burn technologies and the other one is non-burn technologies. One is the burn technology. Under burn technologies, we have incineration and we have plasma pyrolysis. Whereas in case of non-burn technologies, there are four categories of the technologies. One is thermal processes, chemical processes, mechanical processes, biological processes. Therefore, thermal process, we have autoclave, hydroclave, and microwave, whereas the chemical process means we can use the chemical disinfectant. Mechanical process means shredding or combination of shredding and disinfection. Or biological process are also is are the technologies available for us. Let us see what these technologies are. For treatment of waste by the technique or technology called incineration, then how the waste has to be ready. Therefore, now whatever the waste the that comes from hospital to the treatment facility, there will be color coded bags will be there or containers will be there. Therefore, first they have to segregate all the waste depending upon the color coded container. Color coding bags, they have to segregate. They should not dabble with any bag. They are not supposed to. They cannot chant. They cannot remove the tag and they cannot segregate the waste. They are not supposed to do that. Segregation should happen only at source of generation. Then they separate out all the bags depending upon the color coding. Afterwards, the waste is feeded into the incineration. In the incineration process, some heat is generated. Generally, in biomedical waste incineration process, heat recovery I have not seen in anywhere. Only at one place somewhere in Srinagar or Jammu, I think so. Srinagar, I have seen one facility they are going for recovery of heat just for in order to maintain desired temperature because of it is a very cold place. They are generating steam in the process of incineration. The steam they are circulating into the incineration so that they can maintain adequate temperature. Because if it is a very cold place, especially during the winter, it is very difficult. That what are the heat recovery they are doing, that they are trying to recirculate into the system in the incineration process. Therefore, that is really useful for them in order to maintain desired temperature. And we have to have flue gas cleaning and monitoring system. Definitely, it is a must. Flue gas cleaning is a must in order to reduce the emissions which are going through in the form of gas. The system should be there. APCD, that is what I call it as air pollution control devices should be there, so that we can control all the air pollutants which are going to be emitted into the atmosphere from the flue gas. And monitoring has to be done whether the unit when the in the process of treatment of a waste by incineration, whatever the gases so generated, are they going to be compliant to the emission norms or not? Therefore, the monitoring provision should be there as a part of the incinerator so that they can monitor whether the flue gas is compliant to the emission norms or not. Definitely. Then, in the process of waste, which is infectious in nature, because of incineration, the waste is going to be converted into the not going to cause any harm, that is fly ash or ash that will be generated, that is not harmful at all, but still it may not be infectious, but it may likely to contain metals in the form of the dissolve metals may be there. Therefore, it is always necessary to dispose of dispose the ash from the incineration in a systematic way through landfill or by encapsulation. Let us see what are the other things in this.
Sir.
So-
Sir,
yes, sir.
please tell
Yes,
more
please.
about flue gas, sir. Flue gas.
Yeah. Yeah, I will tell you. Don't worry. Wait for a while. We are going
Okay,
in
sir.
detail to that aspect, please. Definitely,
Okay,
I am
sir.
going to cover it up.
Okay.
It is just beginning. We are in the initial stage of the incineration. We'll go to that. I think so. I have modified my slides also only for you people only. I have improved my slides. But technologies. There are burn technology we have open burning type. Means no system will be there. Simply we will throw, put a fire and we will burn it. That is the open burning. Incineration and plasma paralysis. The plasma paralysis, I have told you what are the stages, what will the harmful effects of incineration, advantages and disadvantages of incineration, waste characteristics of incineration, what type of waste can be incinerated, everything we'll see, and what are the air pollution control devices that can be adopted by us so that we can minimize the impact on the environment. You all know there is no necessity to tell about open burning. Open burning is the easiest way of the burning of waste, but that is the worst type of methodology for treatment of biometric waste because it is going to cause impact on the environment. Because open burning is means uncontrolled combustion. Uncontrolled combustion means no control is there. Simply we are throwing waste, putting some the fuel oil, then we are putting fire. That is uncontrolled. There is no any control over the fire. It may spread also. Suppose if there is a wind, heavy wind is there, if there is a waste which is there, which can catch fire and it may cause a lot of damage to the environment. If there is adjacent to the fire, the forest, even forest also may get fire. Therefore, there may be a open burning is not generally called as uncontrolled burning. Just it is going to cause a lot of impact on the environment. There no any control, there no control system. Therefore, it definitely causes impact on the environment. Therefore, open burning is generally not permitted. That's why open burning is prohibited. Open burning is generally prohibited for disposal of waste. It is not at all adopted when there were no systems. No doubt, I know that when there were no systems, definitely there was a what do you call there was a open burning was there. Now after the rules were framed, after the technological aspects have come up, no open burning has been banned. There no any permission. If it is done, then action will be taken against such sort of generators or operators. Now second one, what is the second one? Is this incineration? What do you mean by incineration? Incineration is nothing but combustion or degradation of total organics in presence of excess air at high temperature. Therefore, incineration is nothing but a combustion process or it is the process of degradation of total organics in presence of excess air and at high temperature. Therefore, you are converting all the organic and combustible waste into inorganic, incombustible matter. Therefore, if it is completely combusted, means nothing is there. You cannot go for further combustion. Therefore, you are converting all the organic and combustible waste into inorganic and incombustible matter. And significant reduction of waste volume will be there. Apart from volume, there will be significant reduction of weight also will be there. Suppose if you incinerate 1 ton of biometric waste, you may get 100 kgs of ash. Therefore, 10 to 15% of waste generally
हेलो
will be generated as ash. Yes, please.
हेलो
Yes, please.
सर गुड इवनिंग सर
Yeah, good
सॉरी
evening.
फॉर सर सॉरी थोड़ा डिले होने के लिए सर आज मैं टॉपिक बताएंगे प्लीज मैं क्लास ज्वाइन करने में लेट हो गया कोई फैमिली इशू था
Yeah. Today, we are learning about burn and non-burn technologies, as well as the treatment and disposal options, as well as we are going to discuss on international policy, as well as the liquid waste management, please. Okay.
ओके सर थैंक यू सर
Now we are in non-burn, the burn technologies. I just started only. I just covered what has been discussed in the last week. I just started 2-3 slides only. You can catch up from here. I hope so.
ओके सर
This because of incineration, we also can convert waste. The waste becomes infectious waste becomes the waste harmless. It is not the harmless waste. We are converting harmful waste into harmless waste. That's why we are going for the incineration process. Here, as you all know, carbon, hydrogen is a matter. The matter contains any waste or any. Even if you take human tissues, it is a comprise of what? Nothing but carbon and hydrogen. Carbon. Therefore, in presence of carbon and hydrogen, in presence of excess air, if you convert, this can be converted into carbon dioxide. The carbon is going to be converted into carbon dioxide. In presence of oxygen, if combustion is proper, then there should not be carbon monoxide. If combustion is proper, the carbon should be converted in presence of oxygen. The carbon should be converted into carbon dioxide, and hydrogen should be converted into, in presence of oxygen, should convert into moisture, water, but it is a moisture in the combustion process because the temperature that is in the vapor form will be there is a moisture. Therefore, gases will be generated, ash is generated, and heat is also generated, as I already told, in the process of incineration of a waste. Now, what is the incineration? Just try to understand. This is the simple principle, simple chemistry. I'm not going to give detailed the chemistry. It is a simple chemistry. This is what the waste, whatever the waste generated. Can you see me? My arrow, whatever I'm showing?
Yes, sir.
sir.
Yes, sir.
Yeah,
We can see.
This is the waste that this is the combustion chamber. This is the combustion chamber. And here we are feeding the waste. In order to combust or incinerate the waste, we require air, oxygen is required. We are supplying the air also. Waste is nothing but carbon plus hydrogen, let us say. Now, air means oxygen. Then we are using the fuel, additional fuel, because of the waste which is having high moisture content, then waste cannot be burned directly on its own. Therefore, we have to add some fuel, as well as the fire should be given. There will be a one jet of fire will be there, definitely into the incinerator. Now, after waste is feeded, when the desired temperature is maintained by supplying air as well as the auxiliary fuel as well as the in the form of fire, then the carbon here, you just see here, carbon when in presence of oxygen converts into carbon dioxide and heat is generated. Okay, carbon in presence of oxygen converts into CO2 and heat is also generated. Now, if combustion is not proper, suppose if oxygen what is required for combustion is not adequate, if you are given simple oxygen without any stoichiometric requirement, then carbon, because of lack of oxygen content, it may not be converted. There is no adequate temperature. Therefore, it may not be converted into carbon monoxide. It may be converted into carbon monoxide. It may not be converted into carbon dioxide. Then, if carbon dioxide is generated, it is called as incomplete combustion. Therefore, carbon in presence of oxygen, if it is converted into CO2 as well as heat is generated, it is called as exothermic reaction. Heat is liberated in the process of the combustion. Therefore, if it is a complete combustion means CO2 is generated. If it is incomplete combustion means CO will be generated. CO is toxic in nature. CO should not be there. CO should not be there. Similarly, hydrogen in presence of oxygen is converted into moisture, water, and heat is also generated. Therefore, hydrogen is also fuel. In presence of oxygen, it is going to be converted into the moisture and also heat is liberated. Therefore, after combustion of this waste, by maintaining adequate temperature and pressure, the waste is converted into harmless. In the process, flue gases are generated that is going to be out of this combustion chamber. Here, this is called flue gas. Gas which are going out of this combustion are called as flue gas. And after combustion, the waste which was there as harmful waste converted into harmless ash, that is we collect from the bottom, that is ash. Generally, ash around 10 to 15% of ash is generated. If you burn about 1 ton of waste, you'll get about 100 to 120 kgs of ash. Generally, this what in order to have proper combustion of the waste, you have to maintain three issues. One is their temperature. You have to have adequate temperature and time. The waste should be burnt at some time called what we call it as residence time. It is called residence time. Therefore, at least 2 seconds is preferred. There should be waste. Residence time should be there at least 2 seconds. Why 2 seconds? I will tell you also afterwards. And turbulence. Air cannot be only at one place. Entire combustion chamber, air should be circulated. Whatever the gases so generated, they should be in circulation only. They should not be at one place. Like, because incomplete combustion, CO will form. If it is written there only, no use. If it is goes away, also is dangerous. Therefore, the turbulence of air should be there such a way that it will be at least 2 seconds of time, so that it is completely combusted and CO2 is the converted waste is converted to CO2, and so that they are not going to cause any problem. CO2 is can be minimized. You can reduce by adopting APCD. But the combustion is, my aim is to convert all my carbon into CO2. Therefore, it is complete combustion. Once if I achieve CO2, that is correct. My process is okay. I am sure. I am sure that I have done my waste converted into harmless product. Then no problem at all. Therefore, generally, this incineration will have the combustion chamber with a burner. It is called as burners. With auxiliary fuel supply, the burners will be there. They add like our matchbox. Just will put a light. Then automatically, because of the fuel is going, it catches fire. that that fire can maintain the desired temperature. And also, waste also will have some sort of moisture, some sort of the calorific value. Waste itself will have calorific value. Now, if you see different types of waste generated from the hospital will have different calorific value. Simple example, I will tell you, fetus. Fetus, if it is generated from the hospital, will have high moisture and it will have low calorific value. That means it requires more oil to burn it. One more simple example is waste cotton. The blood soaked with the cotton soaked with the blood. It is a waste cotton or soiled waste. Now, if I throw soiled waste into the incineration process, this waste will have the calorific value, high calorific value than the fetus. Therefore, we have different types of waste will be there. The while feeding the waste generally, they have to see that which waste is having the high calorie value waste, which waste is having low calorie value waste too. Therefore, they have to combine both together while feeding into the incineration chamber so that there is no necessity to have auxiliary fuel, more and more quantum of auxiliary fuel. Therefore, this very important aspect is that it will have a combustion chamber with a burner and waste feeding mechanism will be there and air supply mechanism will be there and adequate temperature provisions, whether the temperature provision is there or not, they will have the systems to measure temperature and the whatever the gas are going out of this combustion chamber will be routed through the air pollution control systems. Then the gases which are free from pollutants will be emitted into the atmosphere, and the waste that is converted into ash is going to be it has to be disposed of into the landfills. Now, I think so. No, we have to have some questions. Why the incineration? If waste is there, okay. Waste which is comprising of the carbon and hydrogen, naturally it can be converted so easily, okay. Now that's why the rules prefers to have segregation at source. Therefore now waste is there, waste like mercury. What you have done is mercury, there is a one thermometer breakage is there, you have mixed the waste, but unfortunately the thermometer after breakage there is a mercury spill is there that you have collected. Of course, last week we have heard about this. We have seen the mercury spill collection. Mercury, once it is collected, that will go for, if it is become a part of the healthcare waste, definitely it will go into the incineration process. In the incineration process, if mercury is there along with the waste, then mercury emissions will be there into the environment. Definitely you can't control because mercury becomes vapor form. Therefore, mercury should not be mixed with other waste so that the emissions can be minimized. Similarly, like depending upon the type of waste, the organic chlorine in the combustion chamber reacts almost completely to form hydrogen chloride. Acids are, you see, gases which are coming out of the combustion chamber is always acidic in nature. It is hydrochloric acids. They are acids because hydrogen is there. Human tissue will have chlorine. कहाँ से आते हैं? Salt, sodium chloride. Sodium chloride, we have got the salt. Our tissues will have sodium chloride. Chlorine is there. When it is mixed with hydrogen, HCl is formed in the combustion chamber, acidic in nature. And similarly, the elemental chlorine also forms within the flue gas. It becomes a part of the flue gas. Other things, if nitrogen, from where it enters, when you are supplying the air itself contains nitrogen about 75%, 79%. Therefore, when it is a participant in the combustion process, along with the hydrogen, the oxygen, naturally NOx is formed. Oxygen, nitrogen oxide is formed. That is also the toxic nature. Therefore, depending upon the type of waste, the emissions also will be there. If there is a mixed waste along with hazardous waste, then emissions also will have hazardous components. hazardous pollutants will be there definitely. Simple example is, if mercury spill is not collected, if it becomes a part of medical waste, if it is going for the incineration, then definitely we can definitely we can estimate that there will be mercury emissions in the flue gas. Definitely mercury emissions will be there. Now, what is the simple system? This is what? This is waste. Whatever I want to go for combustion chamber, I am trying to throw it. I am supplying air in order to, air is required for the purpose. Like we require air, combustion also requires air, so that waste is going to be combusted or burnt easily. And fuel is required, because a waste will not be having adequate calorific value for burning on its own. Therefore, fuel, it is a auxiliary fuel is required, and with this fuel, the waste is burnt here. The process flue gas is generated that will be going up into the atmosphere. Therefore, before discharge into the atmosphere, the flue gases cleaning system should be there. In the process of cleaning of flue gas, we are going to generate some sort of solids that will be in the form of residue, in the form of semi-solid waste. Semi-solid means it be mixture of water, mixture of the moisture as well as the solids. Semi-solid form will be there, slurry form will be there, and flue gas cleaning system, whatever the wastewater is generated from the flue gas cleaning system or air pollution control systems, that has to go for treatment. This wastewater from the APCD, air pollution control systems, has to be treated here. In the process of incineration, also some moisture is generated. That is also has to go into the washings. Generally, floor washings, etc. The wastewater will be there. That also has to go into the treatment, wastewater treatment. Here, the wastewater, whatever is generated from the incineration process, is is treated here. And most of the time, the wastewater so generated is recycled back. It is going to be recycled back to the system here, APCD. They will recycle back here in order to reduce the consumption of wastewater. Treated water is recycled so that they can use for the purpose of control of pollutants into the atmosphere. Now, from the wastewater treatment plant also, some studies generated that is also hazardous in nature. Some type of treated water which is compared to the discharge norms for irrigation, that water is also used for the purpose of gardening purpose. Now, the waste which is generated, which is harmless in nature, that we call it as ash, this has to go for further treatment and disposal, depending upon its constituents. Now, let us see what is this we have. This is what I'm saying, the primary chamber. In the incineration process, we have the primary chamber. Here, the waste is going to be converted from carbon monoxide. Is going to be converted into carbon monoxide generally, because of primary chamber. We are throwing the waste, auxiliary fuel is there, supply of oxygen is there. With the burners and all, the waste is going to be converted into C plus O2 gives 2CO. That carbon monoxide will be taken to secondary chamber, where this carbon monoxide, once again there, supply of oxygen and fuel is there. Therefore, that secondary chamber does not require generally more the fuel, but with light fuel is itself is sufficient, because it can catch fire easily by the carbon monoxide also. Therefore, it catches fire. Adequate temperature is raised here. 1050 is minimum maintained. In case of primary chamber, 750 plus or minus 50 means 700 to 800 degrees centigrade temperature is maintained in the primary chamber, whereas the carbon monoxide is combustible in nature easily. Therefore, temperature generally will be higher in secondary chamber. Therefore, here within the secondary chamber, the residence time of 2 seconds to be maintained, so that the carbon monoxide so generated from the primary chamber is going to be combusted in the presence of oxygen. That later on, the flue gases are, the ash is taken out from the bottom here, and flue gases are going from here to the APCD. These are all the air pollution control devices. All these things are air pollution. This is the emergency exit. Suppose if there is a power failure, APCD will not be working. In such a case, they shut this flow into the APCD, and gases will be emptied into the atmosphere directly without any treatment, because of no power supply. Therefore, this equipment will not be operated. Therefore, it cannot be routed through the APCD. It will be exited through the emergency exit. Emergency exit is also a must for all the incineration process. Any doubt, please? Any doubt?
Okay, sir.
Okay.
Okay, sir.
If you feel any doubt, you can stop me at that point so that you can discuss. No problem. Advantages and disadvantages are, I think so, these are very difficult to read. Accept the greater variety of waste. We can take more quantum of waste, we can treat it easily. Treated waste is unrecognizable as ash. Significant volume reduction is there. Energy recovery is possible, but energy recovery is generally is not happening in biometric waste incineration process. Waste totally dissected and making it harmless. Disadvantages are very expensive process. You have to bear the cost. At least you have to bear at least rupees 30 per kg. Cost of treatment of incineration is around 25 to 30 rupees per kg of waste. Therefore, waste cannot be generated as you wish. You have to minimize the waste generation so that you can minimize the cost of treatment, and also you can minimize the discharges into the emissions, into the environment. You can minimize the impact into the environment. Generally, the gases generated from the incineration is acidic in nature. Because why? Hydrogen plus chlorine reacts with each other in the combustion process and they become hydrochloric acid. Therefore, gases will be hydrochloric acid. Gas is highly acidic in nature. Therefore, generally, these equipments will get corroded very quickly because they are acidic in nature. They get corroded very quickly. Heavy metals will be there depending upon the type of waste. Heavy metals also become a part of ash. If mercury is going along with the healthcare waste for further treatment through incineration, the mercury also will go as a part of flue gas. Some mercury also will be there as a part of ash. Therefore, heavy metals also generally becomes as a part of residue. For example, if medicines, simple example, you all know this field belongs to you. For example, medicines contains some low quantum of heavy metals. Simple example is zinc. If you take any medicine, zinc will be there. If you go for incineration, this sort of waste, definitely ash will have zinc content. Similarly, some nickel, chromium also can expect. Some sort of residual metals will be there in the medicines also. That one is going to become a part of ash definitely. Therefore, ash generally qualifies as hazardous waste because it contains heavy metals. Converts the biological problem into potential air quality problem. Now, before treatment, the waste was highly infectious. After treatment, in the process of treatment of waste by using incineration, we are generating flue gases. Now, the infectious waste has been converted into the problem has been converted into environmental problem like air emissions, air problems, air quality problems. Definitely, we have converted one problem to other problem by adopting this incineration process. And also, major source of dioxin furans will be generated. What is that? I will tell you. Let us go back to the system. Here, the temperature maintained, there will be two temperature I told you, primary and secondary. Primary will have temperature between 700 degrees centigrade to 18 degrees centigrade. Whereas secondary temperature, the temperature will be somewhere around 1050 to plus or minus 50, means 1000 to 1100 degrees centigrade, the temperature will be there. Now, the gases which are generated will have temperature of 1100 degrees centigrade. That means the gases, when they are going for cleaning purpose, high temperature gas is coming, that has to be cooled. We cannot send as such, it has to be cooled. In the process of cooling of flue gases, it has to be done in a very short time. The temperature has to be brought down from 1100 degrees centigrade to less than 450. Otherwise, the toxic constituents are going to be regenerated like dioxin furans will regenerate in the APCD also. If you are not reducing the temperature from 1100 degrees centigrade to less than in between 250 to 4 degrees centigrade, then the reformation of this dioxin furans will take place. That is what we call it as de novo synthesis. We call it as de novo synthesis. That means reduction of temperature of flue gas from coming from secondary chamber to the APCD has to be reduced drastically in a fraction of seconds. In a fraction of seconds, we have reduced the temperature. Otherwise, dioxin furans will happen. Therefore, it is going to cause problem to the environment. Now, pyrolysis. Pyrolysis is one and the same. Both the incineration and pyrolysis are one and the same. Whereas in case of incineration, uncontrolled air is there. Whereas in case of pyrolysis, what is there is whatever the air required for the purpose of combustion is going to be supplied lesser than the quantity. That is lesser than the stoichiometric requirement. Means For the purpose of combustion, we can estimate what is the oxygen requirement depending upon the calorific value of the waste. Then I try to control the oxygen supply into the chamber in order to make the waste into the harmless compound. Therefore, this process is under controlled the conditions or starved conditions. It is called as, we also call it as starved conditions. Under starved conditions, waste can be burned. That process is called as pyrolysis. Therefore, in the process of pyrolysis, generally the gases generated are methane, carbon monoxide, hydrogen, carbon dioxide, and water molecules. The commercial gases formed in the PC due to pyrolysis process are combusted in the secondary chamber. One is the same. Here, rather than supplying higher the requisite quantum of oxygen, here we are supplying the oxygen lesser than what is required as per the stoichiometric requirement. Then the waste is converted to carbon monoxide. Then that converted waste is going to be treated in the secondary chamber, where the carbon monoxide is going to be converted into carbon dioxide. Therefore, that is harmless. Now, what
Sir,
are these
once more,
stages?
sir.
Yes,
Sir,
please.
once more.
Yes, please.
Sir, once more. Once more.
Once more. Here,
Plasma pyrolysis.
incineration is nothing but same process. Incineration and plasma
Okay.
pyrolysis are one and the same. It will have two chambers, ABCD, everything. In the primary chamber, generally waste is going to be converted into carbon monoxide. Carbon plus oxygen
Yes, sir.
gives rise to carbon monoxide, and this carbon monoxide will go to the secondary chamber, where in presence of oxygen and the high temperature, carbon monoxide is also going to be converted into carbon dioxide in the secondary chamber. Whereas in case of pyrolysis, the primary chamber supply of oxygen will be lesser than the stoichiometric requirement. Whatever oxygen is required, that we are not going to supply. We are going to supply at a lesser than what is required as per the stoichiometric requirement, and waste is going to be converted into harmless compounds through the secondary chamber. One is the same here. Plasma pyrolysis is nothing but where we are going to supply the oxygen lesser quantity than the stoichiometric requirement, whereas the incineration is also a commercial process, whereas only in the pyrolysis you are not giving adequate quantum of air supply, and you are giving the controlled the air lesser than the required, and you are ensuring the waste is treated and converting into ash easily. Now coming to this is what? Here plasma torch. Here there is a plasma torch is there, which is generated. There we are using the burner. Here this is a plasma torch. Here the high temperature is generated because of the plasma torch. Under starved conditions, I am not going to give my air supply completely. I am reducing the air supply rate. Waste is fed, power supply is given. The energy is converted into the plasma torch gives the high temperature, the temperature within the chamber. The waste converted into carbon monoxide will go to the secondary chamber, where the carbon monoxide in presence of oxygen will be converted into carbon dioxide. The flue gases will go for flue gas cleaning purposes. Then the system is there that finally the gases will go into the atmosphere. Here the ash is generated. Both are same. Here we use the plasma torch for maintaining the adequate temperature. That is the difference. What temperature conditions one has to maintain, and which causes toxic emissions? If you maintain low temperature than the required, means the rule says 750 plus or minus 50, means 700 to 800 is the desired temperature to be maintained in the primary chamber, and in case of secondary chamber, the 1050 plus or minus 50, means maximum 1100 degrees centigrade temperature has to be maintained. If you don't maintain, the waste is not going to be combusted properly. Therefore, if you don't maintain desired temperature, that causes toxic emissions definitely, because all waste is not going to be converted into harmless compounds. Therefore, it is going to cause impact on the environment definitely, cause a toxic emission. And also, if you don't maintain residence time of 2 seconds, then it causes impact on the environment definitely. If you don't maintain residence time of 2 seconds, that also causes the impact on the environment. Low oxygen, if you don't give complete oxygen, requisite oxygen supply, fuel to waste ratio, that is what you call it as fuel to waste ratio. The fuel and waste ratio you have to maintain properly. depending upon the caloric value of the waste, then depending upon the fuel content required, you have to design, and also depending upon the type of waste that you are going to be treated, you have to ensure that adequate quantum of oxygen is supplied, fuel is supplied, so that you can combust all the waste. Otherwise, it is going to cause the toxic gases. Soil ash also will have the ash, whatever is generated will also will have the toxic constituents depending on the type of waste that you are going to be incinerated. And generally, the ash has to be taken out frequently. Otherwise, it is going to reduce the volume of my treatment of waste inside the chambers. Incinerated slag built up should not be there. No periodic removal means all the ash is going to be built up in the chambers. Therefore, then the volume of my waste feeding cannot be feeded adequate quantum. It reduces the quantum of feeding of waste. Waste suggests I cannot feed as I wish. For example, if the capacity of incineration is about 100 kg per hour, yeah, I can treat 100 kg per hour means I have to treat only 100 kg in an hour. That means 25 kg for every 15 minutes I can feed. For every 15 minutes, I have to feed into the incineration chamber using 25 kgs. I cannot go for more than that. I can go for lesser than that. Suppose if weight is more, 25 kgs is there. But if it is having high moisture, then temperature cannot be maintained. I require more fuel. I require more oil. And therefore, in the process, my cost will become more. Therefore, waste has to be seen in such a way that 25 kg is maintained, but it also will have adequate caloric value. Means combination of high caloric value waste and combination of high moisture content waste has to be seen. That depends upon the operator who is feeding the waste. They have to think all these things. Otherwise, incineration cannot be done properly. Poor gas mixing in the combustion chamber. If adequate mixing is not there, if circulation of air is not proper within the combustion chamber also, that causes toxic emissions into the atmosphere. High halogen content means mainly fluorine, chlorine, bromine, and iodine. If they are there, definitely they cause toxic emissions into the atmosphere. Therefore, these are the things. These are the toxic emissions we can expect, like dioxin furans. If my de novo synthesis, I told if I don't reduce high temperature flue gases emanating from secondary chamber in a fraction of second, then these dioxin furans will be generated as a part of APCD. That will be regenerated in the APCD, air purifier devices itself, because you are not reducing high temperature flue gas from 1100 to in between the range in between 250 to 450, then the reformation of dioxin furans will take place in the air purifier device itself. Suppose if mercury is there as a part of the waste, then mercury waste is also will be a part of flue gas definitely. Emissions of other gas will be there because of incomplete combustion. If any, even toxic constituents will be there as a part of the ash. This is what I want to say. Therefore, these are the types of the gas pollutants can be expected from the biomedical waste incinerators. One is dioxin furans, organic compounds, heavy metals, acid gases, carbon monoxide, particulate matter, bottom ash, and residues. Now, depending upon the type of waste, if you don't maintain desired temperature and desired residence time or turbulence, if it is not proper, you can expect that. And if your control systems are not proper, if your airport control devices are not proper, then the flue gas definitely will have this sort of parameter. The component pollutants will be there that will become a part of environment. In the process, the only the disadvantages in the process of the incineration. Now, impact of toxic emissions from incinerators contribute to global climate change, and it also causes acid rains because the emissions are generally acidic in nature. Therefore, it causes acid rains. Preliminary stages of wherever there is air pollution is there, in the preliminary stages of rain, definitely, generally it will have acid content. Generally, in the preliminary stages of 1 minute, please. The preliminary stages of any rain where there is air pollution is there, we can expect acid content in the the initial stages of rainwater will have acidic in nature. Generally, they will be acidic in nature. If you measure initial stages of rainwater, pH level will be acidic in nature. If you want, you can check it also. Health impacts due to particulates also causes heavy metals and toxic gas also they causes health impacts. Therefore, though you are going to convert infection base into other form of the non-harmless compound, but if you don't take measures for control of air pollution control, if you don't take control measures of the flue gases, it is going to cause impact on the environment as well as the impact on the human beings. Particulates generally they causes these sort of problems like lung function problems will be there. They causes asthma problems, causes other respiratory the symptoms such as cough and bronchitis in children definitely. Therefore, particulate matter will cause impact on the health impacts. It depends upon the size of the particulates. Therefore, depending on the size of the particulate, they cause impact on the human health. Now, impact of heavy metals. These toxins accumulate in the body over time. Suppose if mercury is there, and if it is become a part of flue gas, then if there is a rain, for example, if there is a rain, naturally mercury will become part of rain, and because of rainfall, that rainwater will fall onto the land and water bodies. Generally, if there is a mercury as a part of flue gas, generally the mercury will go into the land, soils, and as well as the water bodies. Therefore, mercury will come through the fish back to us. Food chain. It comes into the food chain, definitely, if there is a mercury. Similarly, ash is not properly disposed of. It contains heavy metals. It may cause impact on the soil or land, or because of the leachate and all, it may cause problem for the other problems. Therefore, depending upon the type of heavy metals, it causes different types of problems for all, definitely, if it is exposed to such sort of. And if gases, definitely, gases also causes impact on the respiratory and cardiovascular systems, and also causes skin and eyes and lungs problems. Eye irritation will be there, skin irritation will be there, definitely, when there is a toxic gases. Side effects such as cough, nausea, and vomiting will be there, definitely, because of the health impacts as a part of toxic gases. Incineration, what type of waste can be input? We can put into the incineration. The basic characteristics of necessary for incineration includes the waste should have calorific value 2000. Can you please tell me, if waste is not having 2000 kilocalorie per kg of calorific value, what will happen? Anybody can react, please? Suppose if waste is not having correct calorific value, what will happen? Yeah, please. Anybody?
Not known, sir.
Suppose if waste is not having adequate calorific value, means waste should be able to burn on its own. If there is a fire, it should burn on its own. That means it has got high calorific value. Paper will have high calorific value. For example, petrol will have high calorific value. If there is a moisture, then we have to require more and more fuel. We have to give more fuel, then only it can be burnt. Otherwise, it can't burn. Therefore, this is the problem. Therefore, waste should have at least the calorific value of 2000 kilocalories per kg. Then content of combustion matter should be above 60%. Content of non-combustible solids should be below 5%. Content of non-combustible fines below 20%. Moisture content should be below, always should be 30%. Otherwise, you require more and more the fuel. If more fuel is consumed, the cost of treatment will go. Therefore, naturally, the emissions also will go up. Therefore, we have to reduce the cost of treatment and minimize impact on the environment by control measures also it requires. Cost is added. Type of waste not to be incinerated. The waste like pasteurized gas cylinders, large amounts of reactive chemical waste, the silver salts and photographic chemicals, halogenated materials such as polyvinyl chloride plastics cannot be incinerated. Otherwise, they are going to cause dioxin furans will be emitted. Waste containing mercury, cadmium, and other heavy metals such as broken thermometers, used batteries, lead-lined wooden panels should not be incinerated at all. Otherwise, it is going to cause mercury, cadmium, and heavy metals as a part of incineration. For example, mercury is there as a part of thermometers. If you make it as a part of waste, then mercury emissions will be there in the emissions, definitely in the process of incineration. Lead acid batteries definitely will have lead, therefore that also become a part of ash content definitely. Therefore, this sort of waste should not be incinerated at all. Radioactive waste also should not be incinerated. Pharmaceutical thermally stable in the conditions below 120 centigrade should not be, the pharmaceutical waste has to be incinerated only at this temperature. Otherwise, it is going to cause problems. What type of APCD should be there? These are the APCD. Means flue gas should have a system like the flue gas, the fabric filters. We use the filters. It is a mechanical equipment, not like a general equipment. It is like a mechanical equipment. Flue gases are coming through this filter so that all the gases or particulates are controlled. The gases free from particulates are discharged into the atmosphere through the stack. Here also electrostatic precipitator. It is one of the best technology which can be used for the purpose of removal of particulates, but it is a costly affair. There are some sort of wet scrubbers. Means, as I told you, the flue gas generally is acidic in nature. In order to neutralize, acids are sprayed over it. Gases are sent through this from bottom, whereas the from top, the acid to neutralize acid, alkali solution is sent. Caustic soda is sent, or lime solution is sent. Therefore, we can neutralize these acidic gases. Then it will be going for other APC, air pollution devices. Wet scrubbers, that is what we call it as wet scrubbers. Cyclones. Cyclones here, it is a by means of cyclonic effect, the gases will be going in the subtler form. The process, they lose velocity of energy. Therefore, in the centrifugal, because of centrifugal force, whatever the particulates which are there, higher particulates, they come down, they fall on its own to the bottom on its own. It is a physical phenomenon only, mechanical equipment. Therefore, this is one of the equipment used for the purpose of control of the particulates. And how to control acids. Acid content, hydrogen fluoride, sulfur dioxide, mercury, and other things are, we have to have the system called, it is called a Venturi scrubber. Through this, you see, gases are going through this from top. Along with this also, the gases are given, the alkali scrubber is given. When it is passing through, it is scrubbed, all the gas are cleaned. The clean gas is going from bottom and it goes for further treatment, please. Here also same, the scrubber, it is a wet scrubber, I already told you. It is like a alkali solution is added in order to neutralize the acid gases. And also, it is a one type of APCD, is called as adsorbents. The activated carbon or activated lime is used when the gases are gone through this way. All the heavy metals, including mercury or dicing furans, can be retained here, and the gases which are free from the pollutants can go through this and finally discharge into the atmosphere. These are some of the techniques. I can't tell you everything, but it's a very huge subject. Incineration itself is a very huge subject. How to remove the NOx? We have to use proper burners. These NOx burner, low NOx burners, what you call it as low NOx burners. Oxygen or the nitrogen will not be there. Low nitrogen will be there. Therefore, in the process of when you supply air along with this the burners, then the nitrogen content will be very low in the supply of air itself. It controls so that oxygen the NOx which is generated from the combustion process will be very less. And also, we use ammonia as a catalyst in order to reduce the various pollutants. That it is called as selective catalytic reaction, where ammonia is used and we try to remove the NOx control. That NOx is the converted into nitrogen and water or moisture by using a catalyst called ammonia in the process of selective catalytic reduction process, SCR. We call it as SCR. Whereas in case of non-SCR means, SNCR means selective non-catalytic reduction means where the temperature is only will take care of it. High temperature will maintain and all the gas are they converted into harmless the gases and it is not going to cause anything. Therefore, these are the techniques. Some of the techniques are adopted for the purpose of control of flue gases. And reduction of organic matter emissions. Primary measures are there like a limitation of the de novo synthesis means by adopting this de novo synthesis we can control the dicing furans emissions into the atmosphere. Optimized conditions. We have to maintain optimized conditions means temperature, residence time, and turbulence. These three T's, we call it as three T's: temperature, time and turbulence, if you maintain properly, then we can minimize the formation of this what do you call this is PCDD means polychlorinated dibenzodioxins, and PCDF means polychlorinated dibenzofurans. These are carcinogenic in nature, highly toxic in nature. Therefore, in the process of combustion, they generate the PCDD and PCDF diazofurans are generated. Therefore, in order to minimize this PCDD, the organic emissions and diazofurans, you take these measures like optimized conditions has to be maintained, and flue gas has to be which is emanating from secondary chamber has to be reduced its temperature to between 250 to 450 in a fraction of seconds, so that this diazofurans will not be formed. Secondary measures like dust separations, we have to use cyclones, filters, everything can be used, and also you can use active carbon filter. Apart from the injection of active carbon into the flue gas systems, that also absorbs the toxic emissions into in the which are present in the atmosphere. This is about incineration and the toxic how to the reduce this. Now we'll go the types of incineration and all we can see. If you do you like to have a break of 5 minutes, please?
Thank you, sir.
We'll have a break of 5 minutes and we'll come back
Okay,
after
sir.
5 minutes, please.
Okay, sir.
I
Okay.
just want to have one glass of water. I'll come back within five
Okay,
minutes,
sir.
please. Okay. Okay. Yeah. Can you start, please?
Yes, sir. Please start.
I actually know it is pure science, purely science subject. Incineration is a completely science subject, actually. You have to bear with me. If you feel boresome, you can ask me. If you feel,
No, sir. No worrying, sir. No worry. It's okay,
okay.
sir. We are all science students, sir.
Oh, wow, wow. Then it is easy task for me. Yeah, yeah, yeah.
Okay,
Definitely,
sir.
you should be a science student only. Therefore, waste incineration is nothing but we require air, waste, and fuel so that we can raise adequate temperature in order to destroy the organic components present in the base. Apart from air, fuel, we also require adequate turbulence and also adequate residence time. What is the residence time required in case of combustion? Is minimum 2 seconds. Is the minimum 2 seconds should be there so that waste can be converted into harmless compounds. The generally air supply rate in minimum 100% excess air should be there for as per generally they design like this. And air supply in primary and secondary chamber shall be related between 30 to 180 percentage, and where in case of secondary chamber more air is required because of carbon monoxide is to be converted to carbon monoxide. Therefore, you have to maintain temperature in between the air supply rate in between 170 to 120. If you are maintaining 30% of air supply rate in primary chamber and you have to maintain secondary chamber temperature around 120, 170. If you are maintaining 80 percentage in air supply rate in primary chamber, you have to maintain 120 percentage of stoichiometric requirement of air supply. That is the requirements. Now there are these incineration can be thermal treatment technologies can be converted to divided into two parts. One is can be divided into two categories. One is those in which waste which are combusted or burned in the presence of oxygen. Therefore, it is called incineration technology. That is what we have heard. And those in which waste are burned in the presence of little or no oxygen, so that there is no direct combustion. That is called as pyrolysis or gasification or thermolysis. Whatever you heard is there are two types of incineration. One is the conventional incineration where adequate oxygen is given, or secondly, especially in secondary chamber, we give more supply than what is required. But in case of pyrolysis, the air supply rate in primary chamber is given very less than what is required in order to combust all the waste. These are the two types of the waste. What are the other types of waste? Are there? The incinerators are generally categorized into four types. What are the? One is small scale, low cost incinerators, single chamber incinerators, double chamber incinerators, and pyrolytic incinerators. And finally, what is one more is also called as rotary. Now, what are these single chamber incinerators? Means if single chamber incinerator is there, this is the single chamber incinerator without any air pollution. That means simple dabba. It is not a open burning, but it is a controlled burning where is adding waste and fuel also, and one pipe he has kept. It is a single chamber incinerator, but he is maintaining desert temperature. It is like a batti. If you see here, this is a double chamber incinerator. It has got one chamber waste feeding. This is also single chamber incinerator only. It has got a burner. Okay, it has got stack pipe through which waste gas are, but it is not a double chamber incinerator. Having heard why single chamber incinerator is not at all suggested for incineration. Can you please guess, please, now? Because of you heard the chemistry in the combustion. Now, if you adopt single chamber incinerator, what will happen?
All the air will be
Yes,
converted
please.
into carbon monoxide. All the air will be converted into carbon
Yeah, yeah, yeah,
monoxide.
yeah. Here, you see, presence of in flue gas, we always measure three things generally. What are the gases are going into the atmosphere? We generally measure what is the oxygen levels, what is the CO level, and what is the CO2 level. If I observe CO2 level higher than the oxygen level, what should be the oxygen level in the gases generally? Naturally, how much oxygen level will be there in the atmosphere? What is the oxygen level maximum?
Oxygen
21%.
21%.
21%, isn't it? And what is the generally you'll observe what is the CO2 level? Very less, isn't it?
5 to 4, less. 5 to
Nitrogen will be there.
4%.
Other gas
Nitrogen
will be there.
99%.
CO2 will be very less. But oxygen will be
4%,
21%. Now, when it's, huh?
Less than 4% carbon
when I
dioxide, sir.
yeah. Generally, oxygen level in the atmosphere will be 21%. Suppose if supply of oxygen is there, if oxygen whatever is supplied in the incinerator is participated in the combustion process, but it is not converted into carbon plus oxygen, not converted into CO2, but it will converted into CO. Now, if CO is there,
Sure.
where it is going for combustion, then no combustion chamber, isn't it? Therefore, it will be emitted into the atmosphere. Therefore, here that's why the single chamber incinerator is not at all, because it is going to cause harmful to the environment. This is what single chamber incinerator. There is a feeding mechanism here. By we open the door, put the waste. There is a I think there is a one like here, they have added one burner. A burner is also there, but the gases are not going to be converted into CO2, or moisture is not going to form. Therefore, this single chamber incinerator is not at all suggested. We are not going for any single chamber incinerator for burning purpose. Now, what is the other one they said? Double chamber incinerator. Now, this is the double chamber incinerator. What is this? This is the one chamber and this is the other chamber. Finally, it is connected with stack. Now, I have fed the waste here. Waste I have converted waste into, I have supplied the air and also I have supplied the fuel, and waste I have converted from carbon to carbon monoxide. Now the gases have gone to secondary chamber. CO is there. I got the burner. I have supplied air, double the required quantity. Now I have converted CO into CO2. What about other gases? In the combustion process, I converted carbon into, in the presence of oxygen, converted into CO2. That is okay. It has complied with my combustion. But waste, if it is waste which is having mercury, let us say, mercury is there as a part of waste. When I treat it through this primary chamber, the mercury became a vaporous form. It is gone along with the fumes here, but it's not going to be burned. It's not going. Mercury is not going to be burned here in the secondary chamber. Only carbon is converted to CO2. But mercury is going as a part of the APCD. Now, if a discharge, any waste containing some heavy metals that are going to become a part of flue gases, and also they are going to become a part of ash. Now, here, double chamber incinerator, I can maintain desired temperature. I can ensure combustion, but there are no any air pollution control devices to control excess pollutants which are there as a part of flue gases. Therefore, double chamber incinerator is also not at all permitted. Not permitted without ACD. APCD is not allowed at all. Now, what is allowed, sir? That is the pyrolytic incinerator. That is whatever you say, I am supplying the water, the air as per requirement of stoichiometric requirement. I am ensuring desired temperature in the primary as well as the secondary chamber, and also ensuring the temperature of the turbulence adequately in both the chambers, ensuring converting my gases into my carbon into CO2. Therefore, and also attached with the EPCD. Now, what are they? Whereas pyrolytic means controlled air. That's why it is called pyrolytic incinerator. Now, what type of this? This is what? This is the primary chamber. Converted, all the gas are converted to carbon monoxide. The secondary chamber where my carbon monoxide is converted into CO2, going away through the APCD where the pollutants are controlled. Then that gases are going to be discharged into the stack, through the stack. Where generally we will have the monitoring provision here. We go for monitoring, that what you call it as stack monitoring provision. And this is the flue gas analyzer. Using this flue gas analyzer, we generally measure CO, CO2 and O2 level. Generally, O2 level should be higher or CO2 level will be higher. Suppose if you measure gas here, O2 level will be higher or CO2 level will be higher.
CO2 level will be higher.
CO2 level should be higher and O2 level should be less. That means CO2 is there means the combustion is complete. Because here oxygen is consumed. You cannot expect 21 percentage. Generally, if CO2 is there more than 12 percentage, generally we feel it is a perfect combustion. Oxygen level, you see, all oxygen cannot be participating in the combustion process. Therefore, some oxygen will be there as a part of the flue gas. If generally any CO2 more than 14 percentage is fantastic combustion. If we achieve CO2 14 percentage, we can feel that the combustion is fantastic and emissions will be very less. And O2, in such a case, O2 will be how much? Total should be 21, but it has consumed about 40% converted into CO2. Therefore, when CO2 levels are there around 14, then remaining O2 level in the flue gas will be around how much? 7% only. Therefore, 14 plus 7 becomes 21. Because the oxygen also has participated in the combustion process. Therefore, the oxygen has the carbon is converted into CO2. Therefore, CO2 level, if I observe 14%, generally my O2 level will be 7% only. That is what. These are the control systems, automatic control systems. It records the temperature, pressures, and also connected with the printer. Printer gives directly what is the temperature maintained over a period of certain seconds. This is in general, this is overall scenario. Just to, as a diametrically, I want to show you. This is the actually this is a rotary kiln. In place of rotary kiln is nothing but it is also conventional the pyrolytic incinerator only. But here, in place of primary chamber, I will have a rotor, means it is like a drum. It will be rotating. You see, waste I will be feeding, the waste will be going, and this whatever the waste is there, that is going to be the rotor where it will be rotating position. It will be rolling like a drum, like cement mixture, cement mortar mixture or concrete mixture. Like that, it will be rotating. The waste is fed. Then, by the time the waste comes from here to that side, at the end of this point, all the waste will be converted into CO2. The length of a drum will decide how much waste is converted into CO or CO2. Definitely, the length of travel from all the way from here to this place. By the time the waste comes, there is a slight slant will be there for this drum. By the time it reaches from here to this place, all whatever the waste is there, that will be converted. Because if it is a burner also will be there, waste will be converted into. Generally, in the rotary, it is a perfect provision. It can convert within the primary chamber itself. Leftover carbon monoxide, whatever is there, it is converted to CO2. Then it is taken to the APCD. These are all the air purification devices. Scrubbers are there. The bag filters are there. Ultimately, the waste is collected, and finally, the waste is going through the stack of height of above 30 meters. The stack height should be 30 meters above the ground level. Stack height should be above 30 meters above the ground level. That is what? It is a minimum requirement. Any doubt, please? This is what I am saying you. This is what the rotor is. This is the rotor where the waste is fed. From this waste will go from here to this end, where this is the secondary chamber. Here the waste is converted completely to carbon monoxide. Then it is going for airport control systems. Finally, I don't see here stack. Stack should be there definitely. Rotakill generally used for the purpose of treatment of huge quantum of waste. We can operate this equipment 24 hours. Therefore, any waste which is there, maybe 2 tons of waste is there per hour, then I cannot go for conventional incinerator with primary chamber, secondary chamber. And rot is the best one in order to treat huge quantum of waste. It can take care of 24 hours it operates. Therefore, 2 tons per hour I can treat. Within 24 hours, I can treat about 50 tons per day. Therefore, I can go up to 50 tons per day. Therefore, wherever the waste generation is high, wherever the waste has to be treated and disposed of is high, then in such a case, you can go for rotary. Wherever the waste is more than 2 tons, then definitely per hour, I am telling you, definitely one will prefer to go for rotary. Rotary is the best one for the purpose of control of emissions also compared to the conventional two chamber systems. I think this is the comparison I already covered. There's no necessity to explain once again. But temperature to be maintained, this is what you have to note down. The temperature you have to maintain is about, in primary chamber is about 750 plus or minus 800. Now, I'm sorry, I was telling 750 plus or minus 50. No. Now it is 800. Primary temperature you have to maintain is 800 degrees centigrade. Whereas the secondary chamber, the temperature to be maintained is 1050 plus or minus 50 means 1000 to 1100 degrees centigrade. Therefore, your primary chamber you have to maintain 800 degree centigrade temperature, whereas in case of secondary chamber, you have to maintain temperature in between 1000 to 1100 degrees centigrade. Combustion efficiency. You see now, if a combustion is proper, I will have more carbon dioxide and I will less carbon monoxide. Therefore, efficiency automatically, if carbon dioxide is more, I can achieve combustion efficiency of 99%. Then what is the resisting time in the secondary chamber? I should maintain as per the rules is 2 seconds minimum should be there. Gases should have resisting time of 2 seconds in secondary chamber. Then the combustion, whatever the incomplete combustion products are there in the secondary chamber, that will be converted into the harmless compounds, then finally it can be discharged. As far as the particle matter limit is concerned, 50 is the limit, but in case of the acid, hydrochloric acid, 30 is the limit. 50 is the limit. Whereas in case of NOx, the limit prescribed under the rules is 400 milligram per normal meter cube. But in case of dioxin furans, you have to remember these limits. For dioxin furans, the limit prescribed under the rules is 0.1 nanogram, 0.1 nanogram toxic equivalent per normal meter cube, and when it is corrected at 11% oxygen. Therefore, always the oxygen should be less than 11% only. It should not be more than 11. Otherwise, this content will be more. Mercury and its compounds cannot be more than 0.05 milligram per normal meter cube. What is the stack height requirement? Minimum stack height above 30 meters, above ground level is 30 meters is the stack requirement, and it should be in line with the all these the parameters has to be complied when flue gases are discharged. Therefore, I just want to repeat once again: combustion efficiency should be 99%. Primary chamber temperature should be maintained around 800 degrees centigrade, whereas secondary chamber temperature should be maintained from in between 1000 to 1100 degrees centigrade, and resting time should be minimum of 2 seconds we have to maintain. And the discharge norms for flue gas emissions norms prescribed under the rules is particulate matter 50 milligram normal cube, NOx is 400, whereas acid mist about 50 milligram per normal meter cube, and total dioxin furans is about 0.1 nanogram per total 0.1 nanogram toxic equivalent per normal meter cube, and whereas the mercury and its compounds should not be more than 0.05. Now, depending upon the type of waste, the emissions also will be there. Therefore, that is based on earlier the thermometers were used. Now thermometers are not in use in most of the hospitals. Therefore, mercury generally can be complied from the incident process. Earlier there was some emissions we have observed. Even I have observed. Stack height should be 30 meters. Now, what type of emissions can be expected from the medical waste incident? These are all the emissions. Particulate matter, carbon monoxide, dioxin furans, hydrogen chloride, sulfur dioxide, nitrogen oxide, lead. If lead is there, generally some medicines will have lead also. Therefore, lead, cadmium, mercury is generally expected in the medicines. If it is a part of waste, if it is incinerated, these emissions can be expected even from the biometric waste incinerators. These are the standards prescribed under in the various countries for the dioxin furans, which is carcinogenic in nature, highly toxic, carcinogenic in nature, and of course, we are in our country we have prescribed 0.1 nanogram toxic equivalent per normal meter cube with the limit. Whereas, of course, if you go to ESA, they are liberal in nature. Japan is far liberal, 5. Whereas other countries like Germany, Netherlands, Sweden, and India, we have suggested the norms for dioxin furans is about 0.1 milligram per toxic nanogram per toxic normal. Let us sum up. Therefore, small scale incinerators generally are there. Thermal treatment systems are there. Thermal incinerators, 2 types generally. One is high and low. In high case, we have got the small scale incinerators comprising of single chamber, double chamber incinerators, drum or field incinerators are there, pyrolytic incinerators. Generally, pyrolytic incinerators are preferred compared to single chamber or double chamber, because single chamber or double chamber will not be having any APCD, and they cannot comply to the requirements. Therefore, generally single chamber, double chamber incinerators are not permitted, or any incinerator without APCD also cannot be permitted. Therefore, generally pyrolytic incinerator with all APCD are generally permitted for treatment of biometric waste. Now, these are the just sum up. Just I want to sum up. Incinerators are there, types are there. What type of incinerators are there? We have like single chamber incinerator, double chamber incinerator, pyrolytic, and rotary kilns are there. Now, this generally Waste energy plant also falls under the purview of incinerator, but generally, biometric waste is not going for waste to energy plants. But generally, the rotary kiln and parallel deck incinerators are generally can be adopted when compared to single chamber or double chamber. Single chamber incinerator cannot be encouraged at all. It is prohibited. It is not allowed in the country. Double chamber incinerator also not allowed in the country without ABCD, whereas parallel deck and rotary kilns are allowed as on date. Of course, these are the incinerator process concerned. Is what any questions, please? Want you can have a break of 5 minutes still.
Yes, sir.
Any questions?
Okay. No, sir.
No. Then you can go for afterwards, and after I think so we'll meet at 3:50 so that we can start with the non-burn technology. I don't want to give at a time more load on you people. I know that is very difficult.
Sir, as well, you are also on load.
No. I can manage because if I can continuously deliver lecture, for me no problem.
Okay, sir.
Okay, we'll break for we'll meet once again at 3:50, please. Okay.
Okay, sir. Okay.
Governor Chandrababu sir is not there.
No, sir.
Ajay Kumar sir, I'm there.
Sir, I mean, something is going on.
No. Actually, no. I want to have some questions to our
Okay.
participants.
Okay.
That's why
Sir.
I'm just making ready. I just why give
Because
break for 5 minutes.
it's a mute, that's why I asked.
That's why I gave a break of 5 minutes.
Yes, yes. Go ahead. Go ahead.
Yeah, we'll come back, please. We'll start.
Yes, sir. Let's start.
So can you see this?
Yes, sir.
Yes,
It is
sir.
visible.
Yeah. This is, if you don't mind, all of you kindly, if you are in a position to see, then you will see this question paper means questions. Which is
Okay,
the
sir.
preferred best burning technology from the following option for treatment and disposal of biomaterial? Which is the best one? Which is the preferred
Plasma
technology
pyrolysis, sir.
for
Plasma pyrolysis.
plasma?
Yes, sir.
Fantastic. What is emission standard limit prescribed for dioxin furans for incinerator under the bomb?
0.1 nanogram.
0.
0.1 TQ.
0.1
Nanogram.
nanogram.
0.1
0.1 ng
nanogram.
nanogram.
Yeah. What is the emission standard limit prescribed for mercury and its compounds for incinerator under bomb request rules 2016?
Mm.
What is the limit prescribed for mercury and its compounds? 0.05. 0.05.
0.05.
0.05
Yeah.
milligram.
What is the prescribed temperature limits for primary and secondary chambers of incinerators under the bomb request rules? What should be the temperature in primary
D, sir.
chamber?
D, sir. D.
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 800 degrees
D,
centigrade in
800
primary.
degrees Celsius
And
and
1050
1050.
to
Plus or minus 50. It is plus or minus 50.
1000 to
Therefore,
1050, sir.
1050 plus or minus 50 means 1000 to 1100 degrees centigrade.
1000 to 1050.
Yeah. That is the limit. What is the prescribed minimum residence time for secondary chamber
Right.
of the incineration under the bomb request rules? What should be the
At
minimum
least
residence time?
at least 2 seconds, sir.
32 seconds.
At
Answer is
At
B.
least 2
2
seconds.
Very good. Then what is the prescribed minimum stack height for incinerator under bomb request rules?
30 meters, sir. 30 meters. 30
30
meters
meters
above
Sir,
ground
30
level.
meter above ground level.
Above ground
Above
level.
ground
30
level.
meters above ground level is the minimum stack height suggested under the rules. Bomb request to be incinerator shall not be chemically treated with as per bomb request rules. Why? Suppose first you understand the question. Suppose why the bomb request which is going to be
To be
incinerated should not be incinerated, the chemically treated. For example, chemical disinfectant is there. Hypochlorite solution. If I use hypochlorite solution for treatment of any waste which is going for incineration, then it causes dioxin furans because of chlorine.
there. Oh.
Disinfectant is chlorine.
Mercury, sir.
Any waste is treated with chlorine, and if that waste treated waste is going for incineration, then dioxin furans will imitate. Therefore, it is disinfectant is the correct answer. Okay.
Okay, sir.
What type of incinerator is preferred among the following incinerators? Drum type, single chamber incinerator, small scale incinerator, double chamber incinerator.
Double chamber, sir.
Double chamber, sir.
No, here also the answer should be double chamber with APCD.
Sir, with?
Double chamber with APCD means air pollution control devices. Okay. Therefore,
Sir.
incinerator,
APCD, sir. Sir.
air pollution
form
control devices. Air pollution
Okay.
control devices. Double chamber
sir.
with APCD is the correct answer. Okay. What type of incinerator is preferred among the following incinerators? Means double chamber incinerator with APCD.
APCD. Okay, sir. Okay.
What is the combustion efficiency of the incinerator prescribed under the rules? What should be the minimum combustion efficiency we have to achieve? If I incinerate any waste, what should be the combustion efficiency I should achieve?
At least 99%, sir.
Wow, fantastic. At least 99% is correct answer. When did the these are not for this next questions already. For the next
17th May 1999.
No.
2002, sir. 2002.
This no, this not for this.
For
the next session,
Stockholm
please.
Convention. This is not for us.
Now we'll go back to the session on the normal technology. That
Okay,
is
sir.
the purpose of. Can you see the slide, please?
Yes, sir.
Yeah. Therefore, non-bud technologies are covered under Unit 23 and 24 of your course. Therefore, we'll have a look at this. There are no much slides. This is very simple, and you can complete within 15 to 20 minutes, definitely. Why we prefer non-burn technologies? Anybody can guess, please? Burn technologies causes the waste is going to be rendered as harmless, but it is going to cause emissions. If it is not controlled, then it is going to cause impact on the environment because of toxic gases may be formed in the process of incineration. Therefore, it is going to cause impact on the environment. Therefore, pollution due to burn technologies, non-burn technologies are preferred. What about the incineration cost? There is a cost involved. For treatment of 1 kg of biomedical waste, I had spent about 25 to 30 rupees of 30 rupees per kg. Therefore, cost of treatment of incineration is very costly affair. Therefore, non-burn technologies are preferred. But for inefficient waste, only burn technologies are permitted under the rules. Non-burn technologies are not permitted. What are these factors? Therefore, what is the capacity, types of waste treated, microbial inactivation, efficiency, whatever you require, environmental emissions and waste residues, regulatory acceptance, space requirement and availability, utility and other installation requirements, reduction of waste volume and mass, occupational safety and health issues, noise and odor, automation, reliability, level of commercialization, technology manufacturer, cost of technology, community and staff acceptance. These are the factors one you have to see for deciding non-burn technologies. All the factors depending upon the funds available, resources available, space available, what is the impact that is going to cause, everything has to be taken into account. Then you have to decide the non-burn technology or burn technology. But whatever the rules specifies, only the technologies has to be used by any operator, any generator. Only that technology has to be used. Specified technologies has to be used for the purpose of treatment of any biomedical waste. But if anybody wants to use any other technology than the prescribed, then they have to obtain, they have to submit the proposal to Government of India. They notify the standard operating procedures, standards, then the technology can be adopted by the generator or proponent. Now, coming to these non-burn technologies can be divided into 4 types. One is thermal processes, chemical processes, irradiative processes, biological processes. These thermal processes are there further divided into low heat thermal processes, medium heat thermal processes. What is this low heat? Low heat one called steam, where we use the steam, hot water or electromagnetic radiation to heat and decontaminate the waste. Where we are using the heat media is the steam or hot water or electromagnetic radiation as a media of treatment of the waste. There are 2 types of waste in case of low heat thermal process. One is wet type, wet heat type, and other one is dry heat process. In wet heat process, what are the types of wet heat processes? Autoclave and autoclave microwave. Similarly, we have dry heat processor also, where dry heat air is used as a media for treatment of waste. This is the difference between the wet heat process and dry heat process. Any doubt, please?
No, sir.
And I think this is your subject only. I should not teach you people. You are well aware of these facts and all. And this is the preliminary basics only. Now, hazards are associated with the wet heat process or dry heat processes. It may a blood splatter may take place, spills may take place, aerosolized pathogens may be aerolized means it may present in the atmosphere also. Exposure to chemicals and hazards, hot surfaces, steam can cause burns. Ionizing radiation is a problem. Noxious odors will come in the process of treatment of non-burn technologies. Noise pollution is there because of motors, equipment which we are using. Non-burn technology is also having some drawbacks. Now let us see what is that non-burn technologies. One is autoclave. Low heat. Low heat. I think so you are aware of all my autoclave, how it works? Because of there's no necessity to explain by me. Autoclave where what is the heat, the media of heat? Steam is used. The doors, the front
Sir,
door, where we feed the waste by having the trolley, and once waste is feeded, it is closed. Once the waste is closed, we use the temperature and we use the steam in order to maintain the temperature in the autoclave. The pressure gauge will be there. You maintain desired temperature and pressure. Once the equipment is operated for a desired temperature, pressure, and duration, then the one cycle is over. Then the waste is taken out and it is discarded as a treated waste. Now, what is the difference between autoclave and microwave? In case of autoclave, we use media of heat is the steam. What is in case of autoclave, the microwave?
Ultraviolet
Electricity,
rays.
sir.
Ultraviolet.
Microwave itself is a energy where you use as a heat of medium to treat the waste. Here, electrical energy is converted into microwave. That microwave is going to cause the treat the waste. It is a simple technique where heat is generated within the mass of the waste, and because of the presence of moisture and because of the heat is generated within the mass, and that is how the temperature is raised. Then the waste is treated in the case of microwave. Because you people are using this equipment day-to-day basis, and we never use this. Only for when I dealt this subject, I have gone and seen. I think you people might be using, Any doubt, please?
We are using autoclave.
Autoclave. Okay. What the temperature you maintain, ma'am, for treatment of biomedical waste through autoclave?
121
121
degrees,
1 degree centigrade.
121
Pressure?
degrees Celsius temperature.
What is the pressure you
Pressure
maintain?
15 pound
15
pressure.
pound per
15 pounds you will maintain
15 pound
pressure.
pressure.
And what is the residence time, duration of treatment?
Duration
32 hours.
processing time 30 minutes, sir. Boiling 30 minutes, processing 30 minutes, and cooling time 30 minutes.
No. It completely duration of
30
residence
minutes.
time, autoclave residence time should be not less than 60 minutes.
60
Means 1 hour.
minutes.
60 minutes.
We have to maintain.
60 minutes.
You see, initially the temperature starts from 0 to 121. Till that time we should not count. When the temperature arrived at 121,
Oh, then 60
that,
minutes, sir.
that is cycle starts. Then we have to maintain for 1 hour, not for 30 minutes. Okay? We have to maintain the cycle from that time
Then
onwards.
60 minutes.
121, pressure 15 psi for a duration of 1 hour. Then cycle completes. Then that automatically the stops. Then cooling process takes place. Then only you can open the door. Isn't it? Okay. Therefore, residence time, autoclave residence time should be not less than 160 minutes. Of course, that depending on the temperature and pressure, the residence time will vary. It may be a 40 minutes if you maintain temperature of 135 degrees centigrade and pressure of 31 psi. Or else, if you maintain the temperature of 149 degrees centigrade and a pressure of 52 psi, then the residence time can be less than 30 minutes, madam. If you maintain 142 degrees centigrade, okay, 149, pressure 52 psi. Generally, whatever the autoclave which I have seen, 121 degrees centigrade, 15 psi, and residence time should not be less than 60 minutes, madam. You please kindly correct it to 60 minutes, henceforth. Okay. Then, how do you ensure?
That is 60 minutes.
Okay.
Sir, excuse me, sir.
Yeah, madam.
That is 60 minutes. I am telling about that 15 pound pressure, that is 30 minutes. So
Okay.
if we exclude that 30 minutes, then total process is 60 minutes, sir.
Okay. Now, can you please tell me how do you ensure efficacy test? When you heard the rules, when we heard the rules, I told you efficacy of autoclave should be achieved at log 6. Isn't it log 6? Do you remember? I gave you mathematical explanation. Log 6 means 1 over 10 power 6 means one spore can survive out of 10 lakhs. Now, there are two tests we have to conduct. Routine test means it is a spore test. It is a strip test. Routine test means strip test. It is a chemical indicator strip that we will put it, but it has to be conducted for every batch. For every batch of the waste treatment through autoclave, we have to use strip test is a must. Chemical indicator strip test is a must, and record has to be maintained. What is the temperature you maintain, pressure you maintain, what is the residence time, and whether you have achieved efficacy or not. And also, you can conduct biological indicator test that are using the indicator of the geobacillus stereothermophilus spores. You can use these spores, and strips can be vials. You can put along the waste. You maintain desired temperature, pressure, and residence time. Afterwards, take out the vial, incubate it. If there is no any change in the color, that indicates no activity. That means you have achieved desired efficacy. If there is a change in the color of the vial, then it indicates that after the incubation, it indicates there is activity. Therefore, you have not achieved desired efficacy by autoclave. Therefore, you have to go for recycle that process. Okay, that is what. Similarly, here, in case of the microwave, I told, what type of waste can be used for microwave for treatment? What type of waste cannot be used for the treatment? Metal items. Metal items you cannot use.
Hazardous waste.
Cytotoxic also you cannot use. Hazardous waste also or radioactive waste we cannot use at all. Or contaminated animal carcasses also you cannot use using the microwave. Therefore, microwave can also be used for the purpose of treatment of biomedical waste. Here, the efficacy you have to maintain using the spores, bacillus, astrophase spores you have to use in order to assess the efficacy of the microwave. Of course, these are the routine things. Other things are there, like frictional heat is there. One technology is there. It is called frictional heat method is there, where I don't know. I have not come across this. I don't know who has come across this. Anybody has come across this? Even I have not come across anywhere.
No, sir.
Actually, it is not suggested under the rules. But anyhow, IGNO has come out with the technology I am just covering, but this technology is not the suggested by under the rules. Therefore, you cannot use the technology. Now, dry heat sterilization. It is one of the technology approved by the Government of India and notified under the biomedical waste rules, where the dry heat is used as a media of heat for treatment of biomedical waste. The temperature maintained shall not be less than 185 degrees centigrade. Generally, you can maintain a temperature of 180 to 185 degrees centigrade, at least for its residence period of at least 150 minutes here. Because dry heat is they are using, therefore the duration is more, temperature is more, and therefore in order to assess the efficacy, you have to use the biological indicators, that is geobacillus stereothermophilus. You can use it as a spore test at least once in 3 months. You have to conduct this test and you have to maintain the, of course, routine tests for every batch. You can adopt this strip used for the purpose of routine test, and record can be maintained. This is one more technology approved into the rules as a normal technology. Other technologies are there, like chemical processes. You can use disinfectants. You can use sodium hypochlorite, that is the cheapest. You can use other the chemical disinfectants also, but it is cost effective. Ozone also you can use. It is a costly affair. And we can also go for combination of both shredding as well as the chemical process. We can go for the combination process. Whereas we have got other things all there. Irradiation-based technologies involves electron beams, where cobalt-60 or UV irradiation is used. The technologies require shielding to prevent occupational exposures. Of course, this technology is also not adopted or not the suggested under the rules. Biological treatment involves the use of microorganisms or biochemicals to decompose the waste. And recently, I come across the NIST, Thiruvananthapuram. They have come out with the technology for conversion of biomedical waste into manure. I think this is what they are talking. But this technology is also not been approved by CPCB or Government of India. But they have made some studies. They have submitted the proposal now. I heard using the enzymes, the biomedical waste can be converted into the manure. That process is under the consideration of Ministry of Environment and Forest. Mechanical process, what I told you, is a combination of both the systems. That means both mechanical process means like autoclave and shredder. Both the combination can be used for the purpose of treatment of biomedical waste. But after shredding and treatment using the combination technologies, segregation is not possible. Then if you are having segregated waste, like only plastics, only different types of plastics, if you are treating, then you'll get only different types of plastics. Otherwise, mixed waste will be there. Therefore, quality of plastics will be vary, and you will not get much cost for when you go for resale of treated plastic waste. Therefore, that is one of the problem associated with the mixed waste. As far as effectiveness in the microbial activation process, I already told log 6 is the best one in order to achieve 99.99 efficacy, especially in case of autoclave. Whereas if you use chemical disinfectants, you can achieve the efficiency of the log 4. It is only 99.99%. This is about the normal technologies. Any doubt, please? Any doubt?
No, sir.
Okay. Then we will go to the next topic. Waste disposal options. What are the on-site treatment options are there? How we can dispose of and all. Treatment and all we have learned. There's no necessary to think. Only we'll go for disposal options only. It is on-site, off-site and on-site treatment options as well as disposal options. What are there? Now, this if you actually know when I show this slide last week, the letters are very small. Now you can see whatever the waste collected from the hospital, segregated waste is there, collected from the hospitals, is transported by the biometric facility operator. You receive the waste here. After receiving the waste, you will segregate depending upon the color coded bags or containers. Recyclable, like red, white, and blue will go for recyclable waste category, and yellow category will go for incineration. In the incineration process, whatever the waste generated means wastewater, a scrubber liquid is generated that will, or wash water, whatever is generated, will go for treatment of through ATP, and after treatment of treated water will go for recirculation in the air pollution devices. Whereas the sludge generated from ETP has to go for secure landfill. Okay. Similarly, whereas it comes to the red, white, and blue category, red is only meant for what type of waste? Red is for what type of waste?
Recyclable plastic.
Plastic. White is for
Plastics.
what? White category?
Surf.
Subs.
Waste shops. Blue category for what? Glass
Surf,
and metal.
plants,
Metal body
Plastic.
implants.
Metal.
body implants.
Now this waste has to be treated using autoclave, microwave, or hydroclave chemical disinfectant. Whatever is available with the hospital, they have to go for treatment. And after treatment, this waste can be segregated, and this waste will go for shredding. After shredding only, will go for different types of disposal options. Chemical autoclaving or disinfection, what are the waste is treated? It has to go for soap washing through detergents. After washing, that treated waste can go for final disposal through recyclers. This is what? After treatment only, recycling of waste is permitted. Before treatment is not permitted. What are the various off-site, on-site treatment options we have to do? That is liquid chemical waste neutralization. Therefore, this is on-site treatment option should be there as a part of the hospitals. What type of treatment option is for liquid chemical waste that has to be neutralized? How to do? You see, this is the liquid chemical waste collected through this tank, and this is the chemical depending on the pH of the chemical liquid. You have to dose has to be applied. It may be acid or it may be basic, depending upon the chemical nature of the liquid waste. If it is acid in nature, then you have to use the alkali solution. If it is alkali in nature, you have to use the acid for neutralization. After mixing here, once the pH is measured, if the pH levels are within the range as prescribed under the rules, then this waste is discharged into the drain or separate drain, which will go for ETP. This is what liquid waste chemical neutralization provision can be adopted. It's like a simple washing machine only. It is not a only dosing provision, correction tank. You have to have one pH meter. Once pH level is acidic or alkaline, depending on that, automatic dosage can be created. One more dosage should be there. One is for acid, one is for alkali. Depending upon the chemical nature of the liquid, automatic dosage will come. It will be decided by the pH measurement. Once it will have a mixture, mixing provision, it will mix. Once pH level is achieved, that will be discharged into the for further treatment. That is what the on-site option for treatment of liquid waste. Of course, using autoclave also you can treat the red waste, then white waste as well as the blue waste also. Now autoclave you can use for treatment of plastics and all. Using this autoclave you can achieve the desired temperature, and this is what I explained already. You can use autoclave as a pre-treatment of biometric waste. Some type of waste requires pre-treatment. What is that waste? Like what type of waste requires pre-treatment? Blood bags, blood samples, microbiology waste, chemical laboratory waste requires pre-treatment. This is what I already explained how the waste is goes. Yellow color waste will go for incineration or plasma pyrolysis. Once waste is treated, where ash is generated, the ash will go for disposal into the landfill. Here, autoclavable waste, red autoclave or even white also will go for autoclave. Blue also can go for chemical disinfection, of course. Red and white can be treated using autoclave. After autoclaving, the waste has to go for shredding. After shredding, the treated waste, both red and stainless steel, can go for recycling activity. Glass also can be using chemical disinfectant, can go for treatment using the chemical disinfectant of both glass and metal body implants. Then after treatment, that waste can go for recycling activity. Of course, we have as a on-site disposal option. Disposal one is deburial. When can you allow the deburial? Anybody can respond?
Sir, where the distance is more than 75 kilometer, or in
Or
a rural area, we can do
where there is no any access to common facility.
access to and in rural
Suppose,
area also.
yeah. In case of deburial, where it is allowed is where there is no any common facility at all. In such a case, the deburial is allowed. Generally, in rural areas where there is no common facility, deburial is allowed to the hospitals. I'm talking about hospital cannot have on-site treatment facility if there is a common facility at a distance of 70 kilometers. That is the difference. Okay. Suppose if hospital is cannot have any on-site treatment facility if there is a common facility at a distance of 75 kilometers. Within 75 kilometers, there is a facility. Then hospital will not be allowed to have on-site treatment facility. If there is a common facility, hospital cannot have any common treatment, the on-site treatment facility. All the waste has to go to the common facility only. Where there is no any common facility, in such a case, hospital will be allowed to have deep burial or autoclave for further treatment and disposal. Choice of disposal options are there. It depends upon the waste characteristics, quantity of waste, options available for final disposal, regulatory requirement, capability of the healthcare facility to handle the quantity of waste. It includes technological options, everything, capacity of the system, volume and mass reduction, environment and safety factors, cost considerations. Everything will be considered into account. Then the disposal options will be decided. What is that disposal options we have? We have deburial, secure landfill, sanitary landfill, encapsulation, resource recovery, pretreatment using neutralization, waste energy, and recovery of fuels or diesel fuels, road making or pavement, use of waste as raw material by iron or found industry. Therefore, all the treated waste will have these sort of options depending upon the type of waste and recyclable, whether the waste is recyclable or not. In such a case, if the waste is recyclable, then that treated waste can go for recycling activity, which also includes resource recovery and, the waste energy or recovery for fuel or diesel oil, or you can go for road making or pavement, or you can use some of the stainless steel materials treated waste as raw material for the purpose of iron and foundry industry. Any waste which is no more having any value, no value, then that waste only will go for second landfill facility. Or if the treated waste is also very dangerous in nature, then that waste will go for encapsulation. What type of waste is dangerous even after treatment of biomedical waste? Which is dangerous one? Anybody can react, please? Waste shops.
Radioactive.
Waste shops are generally dangerous even after treatment because they are shops. Therefore, that waste has to go for encapsulation only. Like ash generated from incineration, that waste can go for where? It is not having any value. Then where it will go?
Secure landfill.
Secure landfill.
Report
Like that,
landfill.
we have to decide. Suppose if secure landfill is not there, it will go for sanitary landfill. If sanitary landfill is not there, it can go for deburial. Therefore, any value is there for treated waste, that waste will go for recycling activity. Any value is not there for any waste, treated waste, such waste will go for final disposal
Secure landfill.
into second landfill, sanitary landfill, or deburial, depending upon the available options only.
Sir,
Yeah,
please give some example of encapsulation.
yeah, I'm showing you. I'm just coming, sir.
Okay.
This is what? Encapsulation means putting entire waste as a part of a solid mass. In a drum, it is a drum, let us say. It is a drum. I kept all my the like waste shops, like needles, everything. Then I just mix semi slurry and I will pour into this. Therefore, it becomes a single mass encapsulation. That means I cannot take out anything from here. It is embedded as a part of cement slurry. Therefore, it becomes embedded. Or
Sir,
anything
saturate.
simple example I will tell you. Any cement concrete pipe is there, pipeline, you can close on the one side and start filling from the other side. Once the pipe is filled up, then you can seal the top other end. That is also called as encapsulation. Means you cannot go and take out afterwards. Understood? Any doubt?
No, sir.
Sir.
This is a cut portion. Just to show the example,
Okay, sir.
this is a cut portion. You see, let me elaborate how it looks. Embedded, all the things are waste are inside. You cannot take out. It is a slurry. It has taken the shape of drum. Even if you cut the drum, from outside, it will have the shape of drum only because it is a cement concrete slurry. Pipeline also you can take one pipe. You can take one pipe, fill all the waste shafts, and pour concrete from top. Cover it. This becomes a solid mass. That is also a encapsulation. This is a landfill where we use the liner of 1.5 mm. Generally, this thickness of the HDPE, high density polyethylene liner is used. Generally, it have a thickness of 1.5 mm. Thickness will be there, and all the waste can be disposed of into this secure landfill. This secure landfill means no waste will go from here into the soils. Once it is filled completely, all the waste will be covered with the soil, and over which the lawn is developed. This is one type of secure landfill. Secured or sanitary landfill. These are the provisions will be there. If the quantum of waste is so huge, depending on the quantum of waste, all the waste is stored. It will have liners of 1.5 mm thick. Then once capacity is achieved, all the hazardous waste. I'm talking about hazardous waste now. This hazardous waste is covered with the soil. The liner, once again liner, the over which about 60 centimeters soil is covered and garden is developed. This is for case of hazardous waste landfill. Therefore, hazardous waste secure landfill. These are the options we have. What are the options we have? Is encapsulation for shops. But all the plastic waste can go for resource recovery. Pre-treatment neutralized or this is hazardous waste has to go for secure landfill. Waste energy, this plastic waste will go for waste energy. Recovery of fuels and all. That means plastic waste can go for recovery of fuel or diesel oil. Road making or pavement. That means all slag also can go for road making. After incident, whatever the slag is generated from ash can go for road making, road filling, low-lying areas. And also you can use the plastics for road making. Use of waste as raw material by iron ore. That means stainless steel, especially the white category waste. Treated waste can go for stainless steel or iron or foundry industries. Treatment and disposal options for the pharmaceutical waste is encapsulation or incineration or pyrolysis or you return to the manufacturers. What are the pharmaceutical waste is there? It can be returned to the distributor or manufacturers, or you can go for encapsulation, or you can treat that waste by incineration. Let us come back to the options and emergency situations is waste pit. No, if there is in case of emergency, then you can go for waste pit as a final disposal of waste. In case of shops, you can go for shops, and ash pit can be used for the purpose of disposal of ash pit also. Deep burial, where there is no confesty, then in case of access to the confesty, then deep burial can be adopted. Where the waste, where the hazardous waste can be disposed of is the secure landfill. All the treated waste of healthcare waste can go for sanitary landfill as a solid waste. After treatment, waste is going to be a solid waste because it's no more harmful, no more infectious. Therefore, if you are not going for any recycling activity, that should go for as a sanitary landfill only. Treated waste can go for sanitary landfill only. That is what. I think so. With this, we have completed both burn and non-burn technologies. Any doubt is there? Any doubt?
No, sir, no.
No doubts. Nobody is asking any questions. I am not understanding. That means I should think that you have understood. Okay then.
Okay, sir.
Then one more topic is very important. I want to cover it up today itself. I think so. Let us continue up to 5 o'clock. We'll complete by 5 o'clock, please. If all agree. Okay.
Okay, sir. Okay.
Yeah, I think so I can complete by 5 o'clock definitely.
Yes,
There's
sir.
no much now. Liquid waste is very fast. I can
Sir,
cover up.
sir, with question answer or without question answer?
Uh, I think so. With
With
question and
question, sir.
answers,
With question answer.
Sir, we
5 o'clock we
expect
start for
question from
with
you, sir.
questions. We may complete by 5:15 also. Questions can be completed
Okay,
now
sir.
very
Okay.
fastly now.
Okay.
Okay.
Does not matter, sir. Does not matter.
Now, internal policies, I don't take much time because of only four issues I had to discuss as per the item number, what do you call this 101, block number 3. Internet policies and the relation with the waste management in the hospitals. That's the topic I had to cover. Actually, today I should have covered these two, but because of I have not covered first class, I have covered till now.
Board
I
number
covered
one.
4 topics. Now, remaining 2 topics I will cover within 1 hour maximum. 1 hour, 1 hour maximum. Okay, because of only these policies are not
Sir,
much.
it's all right. You can continue 1.5 hour also.
Okay,
It's all
if
right.
you all agree, we can go. Otherwise, I'll try to
Uh,
finish up by 5:15,
No, no,
5
sir.
o'clock
You
maximum.
continue, sir. Please
Okay.
continue.
Yes.
Please continue, sir.
Okay. You all heard this is the waste generated from the hospitals, and they are also related with the international policies. What is that? Let us see. What is that? We also have the Water Act 1974, Air Act 1981, Environmental Protection Act 1986 is there. We have Public Liability Insurance Act. Now
Sir,
it is not
no,
there.
no
These have been
PPT scene,
removed.
sir. Sir,
Yeah.
no PPT scene.
Okay. No repetitions. Because of environmental, the improper management of waste, even if you don't take adequate measures for treatment of flue gases in the process of incineration, that are going to cause impact on the environment. That impact will be longer effect. Don't think that.
Sir,
Yes, please. Yes,
excuse me,
please.
sir.
Yes,
Actually,
ma'am.
sir says PPTs are not seeing with your eyes.
Repetition should not be there.
Yeah. No
Sir, we are
PPT,
not able
PPT.
to see. Sir, we are not
Presentation.
able to see the presentation.
Okay, you
Yeah.
are not in a point to see the presentation. Let me.
Yes,
I'm
sir.
sorry. I'm
Yeah,
sorry.
yeah. We
I'm
are
sorry.
asking about that.
I forgot to upload it. Can you see now?
No, sir, only. Yeah, yeah. Please.
Okay, let me upload once again.
It opens international policies BHM-102 block.
Can you see now?
But no.
No? Okay.
No.
Can you see now?
Not yet, sir. Not yet.
No, I'm uploading, but it's not showing. No problem. Let me see. What is the problem? Let me see. Can you see now?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yeah. See, we know these sort of waste are generated. You're all aware now. The industrial waste, municipal solid waste, hazardous waste, used batteries, electrical waste, e-waste, plastic waste, C&D waste, radioactive waste, liquid waste, emissions from boilers, everything is there. Therefore, these sort of emissions are there, waste is generated. Already rules are there for management of different types of waste in accordance with the rules, various rules notified in the EPA Act. Now, if waste is not properly managed, you also have seen what type of toxic gases will be emitted, which includes dioxins, furans, and also like mercury emissions. And what we call it as mercury, generally we call it as persistent organic pollutant. Means it will be once if it is in the environment, it will not go for it will be there for longer time, and it will transport for far distance. You may be emitting in let us say in Bengaluru, that effect may be somewhere in Europe. When you discharge any emissions, the effect may be somewhere else. Therefore, that is called what is called as persistent organic pollutants. It may cause, if you don't take proper measures for management of waste or the control of emissions, that may cause climate change, it may also cause biodiversity loss, it may also cause deforestation, marine degradation, expanding trade and consumption, it will affect. These are the problems of associated with the large global environmental change. Now, in order to avoid the problems from one country to other, there are various international policies have been framed, which have been agreed by most of the countries in the world. What are they? There are like Montreal Protocol. What is that Montreal Protocol? We'll see. Basel Convention is there in order to control transboundary movement of hazardous waste from one waste to others, one country to other. Stockholm Convention on persistent organic pollutants means the any pollutant is there that will be there in the environment for a longer time. It cannot be converted into other form. It will be there for a longer time. That is persistent organic pollutant. Minamata Convention. These are the four conventions which have been referred in the IGNO course. Therefore, we are going to confine to these four international conventions only, not all. Montreal Protocol is for protection of ozone layer. What is the ozone layer? Anybody can say, please?
Hello.
What is the importance of ozone layer?
Sir, it is protected from ultraviolet rays.
Ultraviolet rays coming from ozone.
Then O2 O3.
O3. Ozone is O3. Fantastic. Yeah, you people are told
Prevent from
correctly.
ultraviolet greenness.
Yeah. Let me explain simple way. This is the atmosphere. This is the Earth. Up to 15 to 30 kilometers of this is the lower atmosphere, and we'll have this is the ozone layer. This is the ozone layer. Above 15 to 30 meter, 15 to that means 15 kilometers to 30 kilometers. This is the ozone layer will have. Okay. Now, because the sun rays, all the UV light, ultraviolet rays, which are not harmful to the humankind or animals, are going to protect us from the other rays. The sun rays which are not harmful to us, only that rays will be sent. It will trap that rays, and it will send only the rays, sun rays which are not harmful to the humankind will be sent to the earth. That's why this is the ozone layer. The importance is very important because of discharge of emissions of these chlorofluorocarbons. Generally, we use these chlorofluorocarbons for the refrigeration purpose. Therefore, these emissions are there because it is going to interact with the chlorofluorocarbons, and it converted this ozone. The chlorine is liberated. The chlorine is going to be dismantle this layer. Therefore, harmful rays are going to come onto the earth because of the ozone layer depletion. Whenever because of these the problems, chlorine that is going to react with the ozone, and the ozone layer is going to be the removed. Therefore, it is going to be a problem for us. It is going to cause impact on the humankind. The all harmful sun rays are going to come if ozone layer is going to be damaged above 15 kilometers distance, the above 15 kilometers ground level. Therefore, in order to protect this ozone layer, Montreal Protocol has been agreed by all the countries. Treaty was signed in the year 1987 in order to regulate the production and use of ozone depleting substances, and also to phase out production of ozone depleting substances. That is the importance of the Montreal Protocol. 1 minute, please. I'm getting a call. Yeah, I'm sorry for the disturbance. Yeah, in order to protect the ozone layer, this Montreal protocol has been signed by the countries. Now we have to take measures in order to reduce the consumption of fluorocarbons, and we have to go for alternates, and for which the action plans have been prepared. Now we are going for implementation. We are in the process of implementation of all these the action plans in order to reduce in order to protect the ozone layer. As a part of India also, we have signed this treaty and we have prepared action plan, and action plans are under implementation now. And we are the country have taken a lead in control of active measures, and we are showing the path for other countries also. Yeah, Basel Convention. You see, this is the waste related to uh, the transboundary movement of waste, hazardous waste from one country to other. It controls the transboundary movement of hazardous waste from one country to other. Generally, under the Basel Convention, the hazardous waste is not allowed to transport from one country to other. Any waste is there, which is recyclable. Any waste is there which is recyclable, only that waste can be transported from one country to other only with the prior informed consent only. Only with the prior informed consent. Only with the prior informed consent only. Therefore, in order to reduce and control transboundary movement of hazardous waste between nations, the Basel Convention is the convention, the concerned convention which controls transboundary movement of hazardous waste from one country to other. But any waste which is recyclable can be sent from one country to other who are parties in the Basel Convention, and also but not for disposal. Any waste which is recyclable, they can be sent from one country to other, but these two countries should be a parties to the convention. They should have signed this convention, then only hazardous waste is allowed. Otherwise, it is not allowed at all. And this the treaty convention was opened for signatures on 22nd March 1989, and it came into force on 5th May 1992. Some of the dates you can note down, please. 185 countries are parties to the convention as on date. Haiti and USA signed but not ratified. India ratified in the year 1992 itself. Whereas the Stockholm Convention on Persistent Organic Pollutant means, I told you, any waste which is there in the environment that will be there forever, for longer time. Then we call it as persistent organic pollutant, like pesticides, like like mercury. There is also disulfurans. They're all persistent organic pollutants. And this convention was adopted by the parties on 22nd May 2001 in Stockholm, which is there in Sweden, and came into force with effect from 17th May 2004. Stockholm Convention came into force with effect from 17th May 2004. 181 countries have signed and ratified. Items listed under Annex A to the convention They all permitted for import or export with specific restrictive conditions. Means it's subject to certain conditions. They are allowing for import because of we have to sustain. Without them, we cannot continue our life. Therefore, some wherever though it is banned, but it is continued to be allowed to be used for the purpose, intended purpose with specific subject conditions. And the import export is permitted under the convention with specific conditions only. Reduce and main objective of this convention is to reduce or eliminate release of unintentionally produced persistent organic pollutants, promote use of BAT to control release of persistent organic pollutants, ensure stockpiles are managed safely, implementation plan for control of persistent organic pollutants. India signed this convention in the year 19 in May 9, 2002 and ratified in the year 2006, and national implementation plan under implementation now. BMW rules prohibits incineration of plastic waste. Therefore, plastic waste, chlorinated plastic waste is not allowed for to go for incineration. Chlorinated plastic waste is not allowed to go for incineration. That's why this is the reason, because India is ratified and India has signed this agreement and ratified this agreement. Now ratified means we have agreed for implementation. Therefore, we started implementing as a part of this the convention. Because India is a party, we already started implementing the actions, which includes incineration of polyvalent chloride is not permitted for incineration, and also disulfurans limits have been prescribed. What is the limit for disulfurans for biomedical incinerator? 0.1
0.1
nanogram per nanometer.
0.1, 0.1.
What is the limit for mercury?
0.05.
0.05.
0.05.
millibar nanometer. Yes, please. These all limits were prescribed because we are a party to this convention, Stockholm Convention, which came, adopted by the parties on 22nd May 2001 at Stockholm, and it came into force with effect from 17 May 2004. Some of the dates you have to note down, please. Okay, you can't remember. I can't remember. Of course, mercury is concerned. You all know. I think so. There's no necessity to talk about mercury. Mercury is the only metal available in the liquid form, and highest mercury, the contaminated mercury is the methyl mercury. Methyl mercury is the highly toxic, the constituent, the metal, and once if it becomes volatilization, that comes back to the environment, both on soil as well as the water bodies will be polluted, because mercury always will be there in the vapor form in the atmosphere, and when it comes through the precipitation, it reaches to the water bodies and it causes impact, and it also comes to the food chain. Mercury also comes to the food chain. It may contaminate. If you take fish where there is a mercury content more, then it reaches a different. This is what the mercury, how it comes back to the environment and water bodies. If you take water, it comes into the fish chain, the food chain. Therefore, mercury, it causes a lot of impact and very dangerous element, which is the we have given discuss about how to correct mercury spills and all. I'm not going to discuss about this. Exposure Minamata Convention. Therefore, after there was a discharge of mercury that caused a lot of problem. A place called Minamata. Therefore, this convention came in the year 1956. Globally negotiated international treaty that addresses global mercury pollution and its serious health damage. International treaty and adopted and opened for signature on 10th October 2013 and entered into force on 16th August 2017. Now, recently, of course, 17 only, it had come into force. Then it was signed by all of 144 countries, ratified by more than 88 countries. India signed on 30th September 2014 and ratified in 2018. Means we agreed for implementation from that date onwards. The convention calls for phase out of mercury, ban on mercury mines and phase out existing ones, phase out mercury use in number of processes, control measures to release on environment, waste interim storage and its safe disposal, addresses sites contaminated with mercury and health issues. Now, as part of Minamata Convention, mercury also has been included as a part of norms. Biomedical waste incinerator, it was included. The limit for incineration is mercury emission component is 0.05 milligram per nanometer. Because of this convention, we have signed, ratified, agreed to implement the actions. Therefore, the limits have been prescribed. You all know where the mercury is used in the thermometer, the hospitals. This we have discussed already. How to collect everything has been discussed. Now, effluent discharge norms prescribed for various industry sectors. Wherever the mercury is a raw material is used, mercury emissions are there. There, the mercury effluent discharge norms have been prescribed by the government of India for various industry sectors. Emission norms for mercury for various industrial sectors prescribed, including biometric incinerators, were prescribed now under the EP Act. Therefore, biometric waste incinerators, other waste incinerators everywhere, the mercury emissions norms have been prescribed. In case of biometric waste incinerators, the norms prescribed for mercury and its compounds is 0.05 milligram per normal meter cubed. And guidelines are also given by CPCB, and these guidelines are available for management of mercury waste in healthcare facilities. Yes, please. Of course, these are the gist of the conventions. Of course, I already discussed. I think these are what about the international conventions. Why they have linked with related with healthcare waste is the mercury is a part of minimum health convention. We have suggested various measures. Hazard waste is also generated by the hospitals. Therefore, hazard waste protocols are also there, which has to be implemented by the healthcare facilities, which includes e-waste, lead-acid batteries, and the hazard waste. Okay, pharmaceutical waste is also hazard waste. Therefore, all the hazard waste, whatever is generated, it has to be discharged, it has to be disposed of or in accordance with the respective rules only. Lead-acid batteries also, battery-based rules are there. Whatever the lead-acid batteries are generated, that lead-acid batteries has to be disposed of in accordance with the battery-based management and handling rules. Therefore, because we are a party to the various international conventions, accordingly, because of the commitment made by Government of India, various provisions were included wherever is required. Wherever required, they are included the norms. That is the purpose of having these internal treaties. Okay. Any doubts, please? If no doubts, what I do is you will go for small questions, then I will take up the liquid waste directly. I think so. I will take up liquid waste, then we'll go for. I will try to cover up within 5-10 minutes, then we'll go for 15 to 20 minutes, then we'll go for 10 minutes questions, please. If you all agree. Is it okay?
Okay, sir.
Is it okay?
Okay, sir. Okay.
Where is the liquid waste management? Yeah, can you see my slide, please?
Yes, sir.
Yeah. Yeah, good evening to all once again. Now, this is the last topic which I am going to cover up today, the liquid waste management in healthcare facilities. It won't require much time. I will explain in a simple way within 10 to 15 minutes. Then we'll go for the, what do you call, the questions and answers, please.
Question.
Generally, what is the requirement of the water requirement in healthcare facilities? What is the source of wastewater and the characteristics and the hazards associated with the wastewater? Biometric rules, what are the relevant to liquid waste management? Treatment and disposal options for wastewater in healthcare facilities, the content. These are the mainly various activities which requires water consumption in the hospitals because the various activities within the hospitals, diagnosis, treatment, everything is required. Maintenance of cleanliness, sanitary things, everything is required, and you require water. As per NBC code, kindly note down, as per National Building Code, the number of beds not exceeding 100, they require at least 340 liters per day. Number of beds less than 100, they require 340 liters per day of water. Wherever the number of beds exceeding 100, then they require 450 liters per capita per day. They require about 450 liters per day. Per capita, I'm telling you. Per bed, actually, this is. Now, nurse homes, medical quarters, and hostels per the head requirement is about 135 liters per day. Nursing homes are there, nurses' homes are there, medical quarters are there. In such a case, the per head requirement is about 135 liters per capita per day. Water demand for visitors, at least 50 liters per person per day should be there for visitors because of urinals, lavatory, under the requirement, at least 50 liters per person per day is required for the visitors. Now, taking into account all these things, one has to estimate what the water requirement in the hospital. Generally, any hospital, the uses water, the consumes water. 80% of the water demand will go as wastewater. Will be generated as wastewater. Generally, 80 to 85% of water requirement will be generated as a wastewater in the anywhere. Generally, the water. These are the various sources of wastewater generation in the hospitals. One is administration and wards, operating theaters and ICUs, laboratories, radiology department, the hemodialysis, dental departments, kitchen, laundry and toilets, engineering and maintenance department, runoff from the paved areas. These are the sources from where this wastewater is generated from the hospital. Any other source? Do you agree, please? Do you all agree?
Yes, sir. Yes, sir.
Yes.
Yes, sir.
And domestic, they
Yeah.
like what type of the wastewater is generated, like domestic sewage, culture, stocks, and the associated biologicals, body fluids, used disinfectants, floor washings, including patient areas, hand washings, air pollution control equipment, wastewater, discharges of accidental spillages, including chemicals, laboratory effluent discharges, fire accidents, etc. Therefore, this sort of the wastewater is generated from the hospitals. These are the source of wastewater, generally from patient wards, runoff from paved areas, urinals, bathrooms, laboratories, engineering and maintenance department, administrative office, kitchen, laundries, hemodialysis, radiology, dental department, intensive care units, surgical units, or operation theaters. These are the source of wastewater from within the hospital. Depending upon the type of things, we can categorize this wastewater as black water, grey water, or storm water. And generally, these are the chemicals will be there in the as a part of the wastewater in the hospital. That is important chemicals like formaldehyde, glutaraldehyde, the chemicals from laboratory activities like photochemical solutions, and X-ray contrast media containing absorbable organochlorine compounds, absorbable halogen compounds, mercury from dental amalgams or lab chemicals, excessive nutrients and nitrates, pharmaceuticals, including antibiotics, radioactive waste, infectious agents, including bacteria, viruses, and parasites. These are the types of the constituents the wastewater may contain depending upon the source of wastewater generated from the hospitals. These are elaborated. I have just elaborated, not acquired. The same thing have been indicated. And contaminants in wastewater generated from healthcare facilities generally infectious agents, including bacteria, viruses, and parasites, cytotoxic drugs, waste. Because any patient treated with the cytotoxic drugs, that also comes as a part of urinals. Any residual cytotoxic drugs, that also becomes a wastewater, as a part of wastewater. Mercury from dental amalgam or lab chemicals, if it is not properly collected. If there is a broken thermometers or BP apparatus is not collected properly, then mercury becomes a part of wastewater. Excessive nutrients and the nitrates will be there from the urinals or the bathroom areas. Pharmaceuticals, including antibiotics, etc., are discharged. All these are discharged from the wastewater. Therefore, wastewater generated from the hospitals need to be treated definitely. Otherwise, it is going to cause environmental implications. What will happen if wastewater, untreated wastewater is discharged into the drains? It is going to cause reach the water bodies, because of in any untreated wastewater goes to the water bodies, then there is a depletion of, if there is a excessive nutrients, then eutrophication of lakes takes place, or eutrophication takes place, algal blooms will take place, and biotoxins will be accumulated in the water bodies, and depletion of oxygen level will take place. If there is a depletion of oxygen in water bodies, what will happen?
To
If there is no oxygen content in water body, what will happen? If there is a fish will be there. Therefore,
fish.
if there is no oxygen levels are low, then fish kill will be there in the water bodies. Therefore, that is due to depletion of oxygen levels or accumulation of nutrients, or because of the problems. Therefore, generally, the depletion of oxygen level always causes the problems, and the fish kill will be there. Waterborne disease causes outbreaks of waterborne disease, like Campylobacterus, cholera, hepatitis A and E, cystosomiasis, and typhoid fever, etc. will come. These are all waterborne diseases because of the contamination of wastewater, contamination of water bodies due to the discharge of untreated wastewater from any sources, which includes the hospitals. Vector-borne disease also causes, because of stagnation. It also causes dengue fever because of the development of mosquitoes, and there is a problem also causes like malaria, roundworms problems will be there. Therefore, these are the sort of problems are there. The wastewater has to be, whatever the wastewater generated has to be treated and disposed of properly. What type of standards are there? These are the relevant standards. I think so you all know about these things and all. I don't want to say why unnecessarily repeating these things. Standards, this rule says chemical liquid waste has to be pre-treated. Chemical liquid waste has to be pre-treated. Liquid waste has to be discharged. Before discharge, it has to be treated. These are the standards for liquid waste. What is the pH level? 6.5 to 9 is the standard prescribed under the rules. Suspended solids is concerned 100 milligram per liter. Oil and grease cannot be more than 10 milligram per liter. BOD cannot be more than 30 milligram per liter. COD cannot be more than 250 milligram per liter. Now, bioassay test. If you take wastewater of hospitals, if you conduct if you leave no number of fish in that wastewater, there should be at least 90% of survival of fish should be there after 96 hours in 100% effluent. That is, if I leave 10 fish, at least 9 fish should survive there when I check after 96 hours. Okay, that is called bioassay test. If I take 10 liters of water, effluent from the hospital, if I leave 20 fish in that effluent, if I observe after 96 hours, about 18 fish is live, then it is qualified. Means it is no problem. 90% survival of fish should be there. Otherwise, it is called not going to qualify. Therefore, generally, liquid waste from effluent from hospitals will not qualify this bioassay. They fail. Generally, they fail. Fish will die. Fish will not survive. Therefore, generally, that's why the wastewater has to be treated and disposed of. Suppose if you want to discharge any wastewater, treated wastewater for surface water, inland surface water, then these are the standards to be prescribed. They complied. If you want to discharge into public sewers, these are the limits prescribed under the Schedule 6. And land for irrigation, if you want to use treated wastewater for irrigation purpose, then these are the parameters to be complied by the effluents, treated effluent. Of course, these are the norms. You have to check under EP6, Schedule 6 of the EP rules, you can check. Of course, these are the limits. What will the problem? If there is a direct disposal, no investment, maintenance cost is not there, but is going to cause problems to the water bodies. It is going to cause harmful effect. Harmful bacteria will be there. Therefore, it may cause epidemic may cause directly the wastewater generated from hospital is discharged directly. Co-treatment in municipal wastewater means no direct discharge to environment. Therefore, some of the things can be treated ensured. On-site wastewater, at least you can reduce 90% reduction of pollution load onto the water bodies. If you treat on-site within the hospital, you can reduce 90% of the load on the water bodies. Definitely will not be there. There will not be any problem. On-site plus municipal means the cost wise you can think of. How to discharge? The treated wastewater has to be segregated like domestic sewage, like the hospital wastewater contaminated with inferior wastewater. Therefore, domestic sewage can be discharged by having minimum measures like septic tanks or soak pit can be used, whereas effluent contaminated with inferior waste that has to be treated definitely. Liquid inferior waste has to be treated having by having different treatment plants. These are the type of the system you can have, like bar screens, grid chamber, equalizing tank, aeration tank, followed by clarifier, means secondary clarifiers. Then after treatment of clarifier, you can go for filters. After filtration, you can treat with chlorine. Then you can discharge into. The treated water can be recycled or reused also. Whatever the sludge is generated from the equivalent tank or aeration tanks or clarifiers, that has to go for thickener. And after treatment of this sludge, after dewatering and drying, then that waste can be used for the purpose of as a manure also, if it is compliant to the norms. What are the various systems? Minimum approach of wastewater management in the hospital is at least there should be a septic tank and lined soak pit. If nothing is there, at least these should be there so that they can take care of the other things. Now, these are the provisions can be think of for liquid chemical waste treatment also. Like here, instead of having full-fledged ETP, where the wastewater generated from hospital is very non-bedded hospital, let us say non-bedded hospital, then you can have this sort of provision with a motor and a mixing. There should be a collection tank. All the wastewater collected here, and chemical disinfectant is added here. With the motor, it is mixed, allowed to store for stand for the sometime. The after the sometime, the treated water is supernated, can be discharged into the drain, whereas the city sludge will be there. Frequently, the sludge has to be treated and disposed of. These are the other provisions. Can have provisions if you think of definitely by having this provision, you can discharge all the treat this wastewater definitely. This is what I told you already. What are the systems we have? Let me see. I think so. If you want to discharge this wastewater, you have to have thermal sewage treatment plant should be there. Then the wastewater can be discharged also. Or if you want to treat wastewater on site, then you have to have these provisions like primary treatment tanks, primary treatment provision, secondary treatment provision, and tertiary treatment provision. Primary, you can remove all sort of the heavy solids can be removed by having equalizing tank, chemical dosing tanks, flash and slow mixing provision, followed by primary settling tank. In case of secondary treatment, it is a biological process where the biological activity is ensured, then the dead cells are removed in the secondary settling tank. Followed by tertiary treatment, you can go for pressure sand filtration, followed by active carbon filter. You can remove all the, the, the pollutants which are there in the dissolved form that can be removed. Followed by, if you go for chlorine, then definitely you can ensure the treated water can be discharged directly or you can reuse it. What are these things? Can you have a look at it? What are they? The unit operations. Very quick glance will have. There's no much time now. Therefore, you can. This is what bar screen. In order to remove the floating materials, whatever the floating materials are there, that we can remove using the bar screens. The main purpose is to remove the floating materials so that you can remove all the floating materials which are present in the bar screen, in the wastewater. I'm sorry, where I'm going. Then this equalization tank, what for this equalization tank is wastewater generation from the hospital from different sources is not uniform. It may be coming one time or it may come suddenly also, or more quantum of wastewater also may come. Therefore, all the wastewater is collected here and it is managed to mix it thoroughly, properly, so that it will have uniform nature of the wastewater will be there. Then uniform flow is ensured to go through outlet so that it will not going to affect the next treatment unit. What that is? Chemical dosage. Now chemicals are fed here like generally ferric chloride and the alum and all is added here. Here the wastewater is mixed. The flash mixing thoroughly is mixed. Then it will go for slow mixing tanks where the mixing is done very slowly, such a way that the solid which are there will started coming closer and closer. They become like a flux. Now these flux, why and all, I will tell you. Here in this why slow mixing, because of addition of these coagulants, it is called coagulants. The solids which are there in dispersed form, they're always going to come closer and closer. Then when you are going for slow mixing, these particles which will come closer and closer, their size will become more, so that they can settle down on its own by means of gravity. Therefore, the coagulants are used in order to make the particles which are in dispersive form to come closer and closer to form bigger size particles, so that they can settle on their own by means of gravity. How it happens, let us see. This settlement will take place in the next tank. It is called as primary settling tank. You see this how initially they are in this form. When you after adding the coagulants, they become closer and closer. Then by the time it becomes one flock, means it should be able to settle on its own. Therefore, now in the settling tank, what we do is velocity of flow is maintained such a way that by the time they leave from inlet to outlet, the water, by the time it travels from here to the outlet, the particles which are there, they fall like this. They definitely fall by means of gravity, because the means of gravity here velocity is maintained such a way that the solids particles flocks which are formed in the slow mixing tank will settle on their own at these tanks, so that the solids can be removed from this tank. This is what the purpose is. Next is, there are different types of tanks are there, where the velocity of flow is maintained. Such circular tanks are there, or rectangular and horizontal tanks are there. By the time it travels from here to this here, the particles will settle, and that is removed from this end. And the outlet, this water will go away from this end. The circular tanks, the sludge will be collected from down below, because particles will settle down, because of the vein attached with the circular rotator will be there, that will remove all the sludge. Sludge is removed from here, and treated water will flow, will go like this into this, collect from here. From here it will go to the next stage of treatment. Here, these are the types of rectangular tanks. I just want to show the examples. The circular tank, I just want to show the example. Now, secondary tank, what is the purpose of secondary tank is here, we use diffuse erosion such a way that there is a biological activity takes place. We try to add what you call urea, cow dung and all is added, and ensure that biological activity takes place here and uniform conditions are maintained. Then the whatever the deads, the BOD is there, the organic matter is there, that is consumed, and cells are dead. This even biological activity also will be continuous process. The bacteria also will be dying, and they will be growing because of the availability of nutrients. Therefore, this will happen. Therefore, then from here, in order to maintain the biological activity here, adequate air supply is maintained. Air is supplied in order to have the biological activity thoroughly. Aerobic conditions will be there, and whatever the organic matter is converted into harmless compounds by the bacterial activity. And dead cells will be there. Dead activity cells also will be there. Dead bacteria will be there, and solids will form. Therefore, next stage of this is the aeration process, where they can maintain the adequate quantum of the oxygen in the tanks. Next tank is where here the secondary settling tank, where the cells which are dead, they will have their own gravity. The velocity is maintained in such a way that the dead cells which are having specific gravity of higher than water, they settle to the bottom, and all the sludge is collected from the bottom, that I shown already in the earlier slide. Then after the settling tanks, the treated water will go for filtration using pressure sand filters and active carbon filters. All the wastewater is treated properly. Whatever the wastewater, the solids which are there in dissolved form, all these things will be removed in this filtration stage. Therefore, earlier in floating matter is all the bar screen will remove whatever the particles are there in floating conditions. Whereas in case of settling tanks, the solids which are having specific gravity more than water, that will be settled in which are suspended solids will be removed in the first primary settling tank. Then secondary stage, whatever the solids are there in colloidal form and dissolved form, that will be removed by the bacterial activity, biological process. The third stage, where all the dead cells and the flocks which are formed because of the biological activity, all this will be settled. Now, therefore, afterwards, any solids which are there, toxic constituents which are there in the dissolved form in the water, all these things will be removed in the filtration process and active carbon process. Of course, this is the filter process. I'm not going to explain thoroughly. the not required. Simple filters you would have seen, and you may be knowing all these things also. This is what the flow diagram of treatment plant for a healthcare facility. You see, this is the collection tank. Bar screen will be there. Collection tank, evaluation tank. From here it will goes to, actually aeration tank is not there. Sorry, there should be one tank here. Primary settling tank. Then will go for aeration tank. Then secondary clarifier. From here it will go to the filters, pressure filters, active carbon filters. Once it go over, you can go for chlorination and it can be discharged. Or else if you want to reuse, this water can be reused also. What is the sludge generated will go for sludge drying bed and sludge through filter press, or in a sludge drying drum will be there that can be removed, and moisture is removed. Sludge can be sent to for the what do you call it, sludge drying bed. After drying, that waste can be disposed as a solid waste, or as it can be used as a manure also. These are some of the examples, and uh, I think so. So I could able to fulfill all the requirements, whatever you require. I hope so you understood thoroughly. Any questions you can ask me, please, on liquid waste, so that we can go for further queries on the questions, please. Any questions? Any questions, please? No. Then can we go for questions and answers?
Yes, sir.
5 minutes only. We'll close this one. Yeah, can you see the questions, please? Can you see the questions? Okay, then.
Yes, sir.
Yes, sir.
It won't take more than 5 minutes. We will finish up within 5-10 minutes maximum, please. Okay. When did this international treaty, Stockholm Convention, came into force? Anybody can guess? 17 May 2004.
2004.
2004.
Yeah.
2004, sir.
In microwave, in autoclave, what type of energy is used for treatment of bomb microwaves?
Steam.
Wow. Thank you, ma'am. Correct. What happened
Steam.
to my questions suddenly?
Sorry, it is, sir. Not.
I want to use this. Yeah, sorry. Steam is used as a heat of for to treat the bomb waste. What is the desired temperature and duration to be maintained to achieve necessary efficacy of treatment of bomb waste in case of dry heat sterilization? In case of dry heat sterilization,
Sir, B 180 to 182
180
degrees
180
Celsius.
degree centigrade, and the duration of 1 hour.
Duration
Fantastic.
1 hour.
1 hour.
1 hour.
Yes.
Fantastic. What is the device used for conversion of electrical energy into microwave energy? There is one equipment called magnetron or crystal that converts electrical energy into microwave energy in case of microwave. Okay. Then what type of waste cannot be treated by using microwave? Anybody can guess, please?
Radiological mercury waste.
Radiological
mercury waste
mercury
cannot
waste.
be treated. Yes, please. Then what type of biomedical waste at source of generation is treated using the equipment called demolizer? I'm sorry, this I have not discussed. There used to be olden days. There used to be called one demolizer. It is like a autoclave only. In order to treat small amount of waste shops and waste, that demolizer is used to be used. This I am not told. It is a small equipment which earlier days used to use for treatment of small amount of waste shops within the hospitals. Under what circumstances biomedical waste is allowed to be disposed of in deburial? When can you dispose of
C.
waste by deburial? What is the answer? Where
C.
facility is not available. Fantastic.
Common treatment facility is not available.
UPW
What is
not
the
available.
thickness of HDPE liner used as a base liner to avoid groundwater contamination in secure landfill facility? What should be thickness of HDPE liner?
1.5 mm.
1.5 mm.
1.5 mm HDPE.
Fantastic. What type of biomass is disposed of by encapsulation disposal technique?
Washed surf.
Fantastic.
Sir,
Correct.
sir. See,
International treaties. In the international treaties, there are a few questions.
Sir,
Let me
sir,
ask
please,
you.
please, please. देखा.
Yeah, I think I have rushed.
Yeah.
International treaty Minamata Convention deals with what? Minamata deals with what?
Mercury emission.
ozone
Yes,
depletion,
control of mercury
Montreal,
emissions deals with Minamata
Control of
Convention.
mercury emission.
Yeah, Montreal
mercury
Protocol.
emission. Sir.
Montreal Protocol deals with ozone production
Ozone.
use of
Ozone.
ozone
Ozone.
depletion,
particles.
sir.
Okay. In which year
You are
the
removing the
United
slide.
Conference on the Human Environment organized at Stockholm? Stockholm Convention held in 1972.
72.
72.
1972. When did Basel Convention on control of transboundary movement of hazardous waste and its dumping came into force? 5th May 1992.
5th May 1992.
Who are the main
92.
objectives of what are the main objectives of Stockholm Convention?
Stockholm Convention.
To control
To
persistent
control
organic
persistent organic
pollutants.
pollution.
Persistence
What
organic
type of
pollutants.
toxic and carcinogenic gases are emitted when PVC is burnt under favorable conditions? Suppose if a PVC is burnt, what type of waste are discharged emitted into
Sir,
the
C, sir,
polychlorinated
C.
dibenzo P, sir,
C,
diopsine
C.
yeah
polychlorinated
yeah
dibenzo P furans.
yeah dioxin
Diopsine
sulfurans
and
is correct.
furans.
Yes. Generally, what percentage of total water consumed is generated as wastewater?
80 to 85%.
Suppose if I use
Sir,
100% water,
80
how
to
much is
85.
generally consumed as wastewater? Generated as wastewater.
80 to 85, sir.
80 to
Yes.
85%.
Name the disinfectant generally observed in high content in the wastewater generated from operation theaters. ये आप लोग का सब्जेक्ट है हॉस्पिटल में क्या
Sir,
ग्लूटाराल्डिहाइड है ना
Total
glutaraldehyde, sir.
ग्लूटाराल्डिहाइड
glutaraldehyde. But it is acting as a chemical disinfection, sir.
yes yes
Sir,
discharge of
2%
untreated
before
wastewater
Sir,
into
in
water bodies causes fish kill which is mainly due to what
depletion of
discharge of untreated
oxygen.
wastewater into water
depletion of
bodies
oxygen. Depletion of oxygen.
depletion of oxygen because of the
Oxygen.
depletion of oxygen only the fish kill is there. What is the limit prescribed for bioassay under the biomedical rules for discharge of wastewater generated from hospitals?
So 90% survival of fish after
90% survival fish.
96 hours. I'm sorry, there is a spelling mistake.
96 hours. Sir.
96
Yeah,
hours.
yeah, 96 hours.
There is a 96 hours. Yeah, yes.
After exposure
Our
in
exposure in
100%.
100% effluent.
Yeah, chemical liquid waste is required to be neutralized depending on dash parameter.
pH.
Yeah, correct.
pH.
What is the preferred treatment of liquid waste generated from non-bedded hospitals? I showed you one example.
Yeah, 1 to 2% sodium hypochlorite.
Yeah, yeah,
1
yeah.
to 2%
Non-bedded
sodium
hospital is
hypochlorite.
concerned, 1 to 2% is used.
Only
Otherwise, you have to go for
sodium
full-fledged
hypochlorite.
wastewater treatment plant. Yeah. Yeah, I'm sorry. I bothered you people because of my problem on first time class. Today I have tried to complete all the subjects, whatever I have committed to the IGNO. I think so. I have done my best, whatever I could explain to you people within the available 4 hours. And still, if you have any
Yes, sir.
questions
Yes,
or
sir.
any doubts, already I given you my mobile number, contact details. You can talk to me anytime you wish.
Very interesting
Okay,
class,
sir.
sir. Very interesting class. Thank you,
Any
sir.
Sir,
Thank you
comments?
very
sir,
much.
sir, please.
Please kindly give me any comments. Any comments? No
Thank you.
comments?
No
Thank
comment, sir.
you,
Sir, thank
Chandrababu
you,
sir.
sir. Thank you, sir.
Thank you,
Sir,
sir.
come
Thank you
on,
very much.
please. All of you, please come on video, please. All of you come on video, please. Just want to have a look at who are there and all.
Your camera is on.
Thank you very much,
Yeah.
sir, for your
Thank you
marathon.
much.
I mean, we are salute to you. Means 2 to 5:36 teaching non-stop. I really thanks core of my heart on behalf of the IGNO family, on behalf of School of Health Science, on behalf of Regional Bhubaneswar. I'm
Nine, nine.
really thankful to you, sir. It's a
Sir,
really
actually,
Allah.
credit
Allah
goes
will
to
bless you.
the participants, sir. They are encouraging me. They are not feeling bored. They're not feeling
Yeah,
well,
yeah,
and
yeah.
therefore I could be able to continue till now. Otherwise, I
Because
would have stopped last year back.
I thanks to my participant out of their busy schedule, they all are doctors. After that also, they which way they are giving answers. I am really thankful all of you.
No, no, sir. I'm definitely, sir. I'm there. Whenever, if anybody wants to have my lectures in their hospitals also, they can invite me. I can participate through VC. Definitely, I can do my best, and I can help them also. No problem. Not necessarily the participants should get the knowledge.
Thank you, students. Because you are not students, you all are professionals. You all are doctor. After that also, you are pursuing this course. You are really thankful to all of you.
Thank you, sir.
Let us hear from the
Okay, thank you,
participants,
sir.
please.
Thank you.
Yeah,
Thank you,
tell.
sir.
Let us hear from
The
the
classes
participant,
are
Dr.
very
Ashok
useful.
Kumar, sir.
Thank you, sir. Thank you very much. Very interesting class, sir. We
Thank you very much, sir.
actually very much thankful to you, sir, for your class.
Thank you very much. Thank you very much. Okay, when there is a chance, if you want to
Sir.
invite me for your any programs, you can invite me. I can participate through definitely through VC, please. Thank you all once again for bearing with me for 4 hours. Definitely, you have spent. I hope so. You enjoyed a lot, and you have gained a lot of knowledge, and which are useful to you. And definitely, you all will completely get good success. And wish you all the best. And all of you once again, happy Dasara to all of you also, please.
Thank you, sir.
Thank you, sir. Same to you. Thank you.
Okay, bye. Okay, bye. Okay
To
then.
you, sir.
Bye.
Hello. Hello.
Hey, your microphone is
Yes.
on. Stop recording, but stop record, stop
Sir,
recording, cancel.
our session is over now.
Yeah.
Stop recording button.